Alright, hello grade. Is it grade 11s, eh? Grade 11s, eh? Yeah, grade 11s, grade 11s, grade 11s. Yeah, guys. Let's get ready to rumble. Right. Which grades are here? We have grade 10. We go back to 11. Grade 11, grade 11, grade 11, grade 11. Grade 11. Okay. Hopefully we are ready. We're ready as always to do what we are ready to always. Okay, please share the live with any grade 11s that you know. Alright, especially if you are grade 11 and you're writing tomorrow. Right. Grade 11 and you're writing tomorrow. Pure maths. Okay, grade 11. There's only one grade that we do here. Grade 11, guys, all the way. Grade 11 and grade 12. This is your time to shine. Okay, grade 11 and grade 12. But of course, a question like this would be appropriate even for grade who? For grade 10. Grade 10 would be able to answer this question. So would a grade, was it a grade 11 or grade 12 learner would be able to answer a question like this. So we're going to answer this question paper one step at a time. We're just gonna, reveal and answer, hey? Because obviously basics are important as much as complex questions are important. So going to unravel it one bit at a time. Hey, go. My friend, my brother from another mother. I thought I saw you live just now. I think I saw my brother from another mother live literally a few minutes ago. Now I see you join as a guest here on my live, unless I'm seeing things. Okay. Kanye, x is equal to 5. Kanye says. Okay, guys, here, very important, guys, that when we have a equation, yes, answer, guys. When we have an equation, a quadratic equation, okay, as we write any exam, guys, we need to check the mark allocation and we need to ensure that we do a question within the time that the mark allocation says. So 2 marks shouldn't be something that you spend more than 2 minutes answering. So 2x squared minus 50. First step in this question is we can see this is a quadratic equation. The highest exponent of x is 2, and so we're expecting at most 2 answers. Okay, that's good, Kanye, that you did it without pen and paper. That means you are phenomenal. You are by far a phenomenal student, that's for sure. Doing it without pen and paper is something that's extremely good. Okay, since the highest common factor is a numerical value, okay, we divide the left and the right by what? By 2. That leads us to x squared minus 25 is equal to 0. The equation is now simplified. Okay, so if the highest common factor is a number, all right, we divide by it. If the highest common factor is a number with a variable, we take it out. Okay, so we must always check, is the highest common factor a number? Which in this case it is. It's the only thing that is the highest common factor. So we divide each term in the equation by that number if we have an equation. Then that leaves us here with x squared minus 25. What do we see here? A difference of two squares. X squared minus 25. So we open two brackets, equal to 0. The one bracket is positive, the other one is negative. We have x here because the square root of x squared is x. The square root of 25, we have 5 and 5. And basically that leads us to our factor form. So we have a standard form. We then have the factor form. After having the factor form, we apply the 0 factor law, which means x plus 5 will be equal to 0, or x minus 5 will be equal to 0. Two answers then will result, that is x is equal to negative 5, or x is equal to 5. If you look here, it didn't take me more than 2 minutes to answer this question. All right, that's how it should be. So as I said, we look at the equation, we check what type of equation is it. It is a quadratic equation. But we look at the expression on the left. Is there highest common factor? There is. Is it a number? If it is, we take that number, we divide each term by it. If it was a letter and a number, guys, we would take it out of the bracket. We wouldn't divide by it. We only divide a highest common factor if it's a number. Then we have our standard form of the equation. We can factorize it. We apply the 0 factor law. We get the roots. And that's that. Question 1.1.2. So same thing, you look at the equation. It's in standard form. It's a quadratic equation. So at most, you need 2 answers at most. Then you check, can you factorize? Highest common factor is 1, it's not significant. Can you do anything else, guys, with this? Are there factors of 9 which when you multiply give you negative 9, you add, they give you negative 3? Such do not exist. So what we then are left with is to use the what here? The quadratic formula. So in as much as 1.1.1 factorization could happen, 1.1.2 needs the quadratic formula. So the formula, guys, is only utilized if the equation we already have it in standard form. The a, b, and c value are respectively 1, negative 3, and negative 9. So our standard form of the quadratic formula, here it is. We go ahead and we substitute our values a, b, and c. A is 1, b is negative 3, c is negative 9. So in brackets, negative, b is negative 3. So we write negative, negative plus minus the square root of b squared. B is negative 3 in brackets squared minus 4a. A is 1, c is negative 9. Over what? Over 2. A is 1. Okay, one more stage. Negative times the negative is positive 3. 1, 1 to 1, 1, 1. 1 here, 1 number there, 1 number there. 3 squared, negative 3 squared is positive 9. Minus 4 times 1 times negative 9 is positive 36. 36 plus 9, 45 over 2. Now the only thing left is to use our calculator. I want to check with you guys. If you substitute your values, you get your answer. What are the two values of x? Let's see in the comment section. Remember that they said solve for x. And I guess in places where it is appropriate, they said round off to 1 decimal place. So where and where do we round off to 1 decimal place? It's going to be here. So if you guys punch this in your calculator, the two answers that I get, let's see if you guys can also round them off to 2 decimal places. Express your answers as values of x rounded off to one decimal place. You can all type in the comment section with your answer. I just want to see what each individual is going to be coming up with. What is the answers you guys get from your calculators? Okay, I'm waiting very patiently, guys, for you to tell me what are your answers. Waiting very patiently for your answers, rounded off to 2 decimal places. Seems like our people in the comment section are very, 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 very passive. No one is typing in and checking the answer. Okay, guys, I'm guessing if you guys are not non-participative, I guess I'm just going to have to pull out on this live, because that means I have ghosts in my life. Ghost learners. I'm awaiting, as I await the answer. Round it off to 2 decimal places. What's the answers, guys? Okay, finally, someone actually answered 4,85. Yeah, I was actually gone because I thought to myself, I guess they're not participating. 4,85 or negative 1,85. Thank you, Star Black. Star Black, you're so kind, and thank you, L and Fumani Shabangu. I really thought that you guys are, you're just basically deciding that you are not going to participate. You're not going to be any part of this. I might as well go it on my own. Okay, so thank you so much, guys. Really appreciate you. Next question. 2x minus 3 into x minus 1. Now, guys, the caution we need to have here is very evident. You see this stage of the question. We have x plus 5 into x minus 5 is equal to 0. I did a video on this and I put it onto the TikTok page because learners tend to think the zero factor law, where you have a product of factors equal to 0, where you take x plus 5, make it equal to 0, x minus 5, make it equal to 0, and solve. They tend to think that the same thing you do with 0 is the same thing you would do with another number. And that is not true. Okay? That is not true. In essence, we know that's not true. That's not what we do. So, obviously, if there is another number, we don't do it. Ducks,
Yes,
what's up, Bob?
what's up? I see you are solving math problems here.
Yeah, we are solving math problems because grade 11s are writing tomorrow.
Oh, with grade 11s.
Sorry?
It's grade 11s.
Yeah, grade 11s are writing tomorrow.
Oh, I thought it was maybe
It's the
yeah,
same
the same.
thing as far as equations are concerned. Yeah,
But there's only a little bit of work that comes with this one. You see,
true, true.
sure.
Okay.
But you can
Okay, I'll proceed. So here we have 2x minus 3 into x minus 1 is equal to 15. So what we did here, all right, was appropriate because we applied the zero factor law, taking each bracket, equating it to 0 and then solving for x. But if there's another number, we don't do that. So when there's another number, we can't take 2x minus 3 and say equal to 15 and then say x minus 1 equal to 15, because the law is not the another number law. It's called the zero factor law. So with this one, you have to go ahead and expand, apply FOIL, and then transpose the 15. So what we're going to get there is 2x squared, of course, because 2x times x is x squared. 2x times negative 1 is negative 2x. 3 times x is negative 3x, and then 3 times negative 1 is going to be positive 3. You transpose the 15, we get negative 15, okay, which is what we know. Then obviously 2x squared minus 2x minus 3x is minus 5x. And then 3 minus 15, that gives us what? Negative 12. Then I know some people will go ahead and they will take the quadratic formula and use it to solve for this particular equation. Why? Because of the unfamiliarity that we tend to have, of course, with that. And that's fine, right? If you decide to use the quadratic formula here, that's 100% fine. And I suppose that's probably the best course of action, right? X is equal to minus b. Okay, then what we do is we actually say minus 5, b squared minus 4ac over 2a. 2a, 2 times 2. So that is 5 25. 4 times 2 is 8. What's 8 times 12? That gives us positive 96 all over 4. Then 25 plus 96. 25 plus 96, that gives us 1. 1. 121. Very good. Thank you, L. Over 4. And that's with obviously 5 plus minus 11 over 4. And I suppose you actually could have factorized that. But of course, we decided to go this route. 5 plus 11 will give you 16 over 4. That's one of your answers. Or 5 minus 11 will give you negative 6 over 4. So 4 or negative 3 over 2. Two answers. X is equal to 4 or x is equal to negative 3 over 2. Okay, so some obviously would have gone ahead, factorized, and gotten the answer, but decided here to basically use the quadratic formula. There wouldn't be a train smash in doing that, because at the end of the day, it leads us to the answer, right? Yeah, so that's the beauty of that quadratic formula, and especially now in this grade, okay, you can utilize it because it's there for usage, right? It's there for usage. It's there for you to use, right? So that you can be able to get 2 answers. All right, so that was a beautiful 5 marks that, we were asked about there. No problem. Not a train smash, right? These are giveaway marks that you should be getting nice and easy. Okay, gets you off on a good start with the paper. Okay, the next one, 1.1.4, fraction equations. Guys, hopefully with fraction equations, we know the procedure. Okay, with fraction equations, especially this type, all right, there is that thing of saying, step 1, you look at the denominator. It's just to get an overview of the procedure. We look at the denominator, and when we do so, we factorize the denominator if possible. So if we look at x plus 1, it's a matter of putting this in brackets. Look at 2 minus x. Guys, what do we do with 2 minus x? What is it that we apply again with 2 minus x in the denominator? Because x is basically, it's a second term, and it's negative. We don't want that. So there's this special type of procedure that we apply in the denominator to ensure that the order is your x term first and your constant next, especially when there's a negative sign in between. We call that the what? We apply a procedure called the sign change rule. Yes, MJ, the change of the sign, called the sign change rule. Okay, we change the sign of positive, we allowed to change the order. That's a type of factorization, if you want to call it that. So that is our first step. Look at the denominator, factorize if possible. So plus becomes negative 3 over x minus 2. You see that positive sign changed, then the order changed for your negative sign in between. 1 over x plus 1. So you kind of put your denominators in brackets to show that you've taken out a common factor of 1, you've taken out a common factor of 1. That's step 1. Look at your denominator, factorize if possible. Don't forget the sign change rule. Okay, so you need to know how to factorize. All your types of factorizations need to be known. Step 2, you need to write down your LCD and your restriction. So what will the LCD be? X plus 1, it's common for 2. So we regard it as a leftover, but since it's common, you write it once. X minus 2, it's a leftover, it's unique for this term. You write it as a product with x plus 1. That is your LCD. LCD done. Restriction, what values of x can x not be in the denominator? We want to avoid having 0 in the denominator. So what are the values that x cannot be? The minute x is negative 1, that will mean this denominator will be undefined. So we say x cannot be negative 1. Or the minute x is 2, 2 minus 2 is 0, so x cannot be positive 2. The restriction is important. Okay, so step 1, look at the LCD, factorize. Step 2, LCD and restriction. Step 3, multiply. Multiply what? Multiply each term in the multiply each term in the numerator so that you can eliminate the denominator. So you take the LCD, imagine putting it there at the top and multiplying it with this entire fraction. What happens? The x plus 1 and the x plus 1 cancel. Then what gets left over? X minus 2. Okay, but since you have a binomial at the top, please ensure that you have, if you have 2 or more terms in the numerator, you put it in brackets. So the leftover x minus 2 gets multiplied with the current x plus 2 that is present there. Okay, Same LCD, you multiply by it there in the numerator. What happens? The x minus 2 and the x minus 2 will cancel. You are left with x plus 1. So we're going to say minus 3 into x plus 1. Guys, are you understanding what I'm doing here? We are multiplying each term in the numerator by the LCD. So if you multiply each term, you see, in the numerator by the LCD, the x plus 1 and the x plus 1 cancel. You get left with x minus 2 to get multiplied with x plus 2. Okay, so the brackets need to be there for both. The negative 3, the x plus 1 and the x plus 1 stays behind, x minus 2 disappears because it cancels with that x minus 2 in the numerator. Here, equal 1. X plus 1 and x plus 1 will cancel, x minus 2 gets left behind. So it's like who gets taken, who gets left behind. We take, gets left behind. We take, it gets left behind. We take, 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 gets left behind. You see, so all the left behinds, x minus 2 was left behind because x plus 1 was taken. X plus 1 was left behind because x minus 2 was taken. X minus 2 was left behind because x plus 1 was taken. Does that make sense, guys? Then you are left with this. That's what you do, guys. You multiply each term by the LCD. Iminati Scott, you are saying, can you help me? But you are here, so I don't understand what you can be meaning by can you help me? You are here. So what is the issue? Iminati Scott is here. She is saying, can you help me?
Hello.
Hello, Iminati Scott.
Wait, how are
Iminati Scott. Guys, I wish you could listen to that song by Peanuts that says Iskatso Dlala Asnas. But I feel like I think some of you you have time to play. Okay, so the person who was asking why, I don't really have time to play. Okay, learners are writing tomorrow and some of you are just coming in. All right, you breathe very heavily on the mic and then you ask no questions. All right, I don't know why do you do that. Okay, why did 2 minus x change to x minus 2? Guys, look at your expressions in the denominator. X is first, constant term follows. X is first, constant term follows. This one is departing from the order. So you have 2 minus x. Typically, the x must be first, the constant must follow. So this 2 minus x, if we take out a negative sign, what happens is that you can place the x first, because taking out a negative means the x is going to change to positive. And then this 2, which was positive, is going to change and be negative. Then the negative that you took out gets multiplied with this positive and becomes negative. So now you have an x minus 2. Check what can happen. If you were to take this minus sign and multiply it with the x, don't you get the negative sign back? Yes, you do. If you take the same negative, you multiply it with negative 2, don't you get this positive 2 back? Yes, you do. So this is what we call the sign change rule. It is applied whenever we have two terms. The sign is negative in between, and we wish to change the order. What we do is we change the sign outside, we change the order of the terms so that the x term features first and the constant term features as a second term. So that's the sign change rule, guys. After factorizing the denominator, you find the LCD and then you find your restriction. LCD, x plus 1 and x plus 1 are common for two fractions. The leftover, we take what's common, the common base with the highest exponent. So x plus 1 can be taken once. X minus 2 is unique. So it becomes a product with x plus 1, and it becomes your LCD. Then you check what values of x will make these denominators 0. What x values do we want to avoid featuring as the answers which will be substituted in the denominator? X cannot be negative 1. We don't want negative 1 being there, because negative 1 plus 1 will give us 0 in the denominator. We don't want x being positive 2, because 2 minus 2 will give us 0 in the denominator. So these are the restrictions. After doing so, writing down the LCD and the restriction, we multiply each fraction term in numerator. Why do we multiply each fraction term in the numerator? So that we can get rid of the denominator. So if your LCD has been written down correctly, what happens is that by multiplying each fraction term in the numerator by the LCD, this x plus 1 and x minus 2 you will put there as multiplication in the numerator. But the x plus 1 and the x plus 1 will cancel, leaving behind x minus 2 to be multiplied with x plus 2. That's what you see. Okay, here. Thank you, Lerato, for the love you and the GG and the rose and every other gift. I really appreciate you so much. Okay, thank you so much. Let me just do this. Let's celebrate all gifts that come my way. I really appreciate it. Thank you so much. You be blessed immensely. You have needs, you have desires for yourself and your life. So whatever it is, my guy, because of the generosity that you are basically displaying here, may you be blessed immensely. And I really appreciate it like you have no idea. So like I said, guys, you take that LCD, you multiply by it in the numerator. Okay, so that x plus 1 and x minus 2, when you multiply by it there in the numerator, x plus 1 and x plus 1 cancel, x minus 2 gets left behind. It gets multiplied with x plus 2. That x minus 2 and x minus 2, when you multiply in the numerator, x minus 2 and x minus 2 cancel, x plus 1 gets left behind. That's why you have minus 3 into x plus 1. You multiply by this in this numerator, x plus 1 and x plus 1 cancel, x minus 2 gets left behind, getting multiplied with 1. Now we are ready to multiply out so that we can rush for standard form of the equation. Okay, so now let's do it. We can FOIL here. Okay, all right, you can FOIL. Thank you so much. Thank you so much, Lerato. You are very kind, brother. I appreciate even the generosity in your words. Yeah, you be blessed in everything that you do. Thank you so much. Okay, so x, we can see that this is the reverse of difference of two squares. So we can get straight to the point. We know this is going to be x squared minus 4. Those who have eyes to see know that, because x times x will give you x squared. X times 2 will give you 2x. Minus 2 times x will give you negative 2x, and then negative 2 times positive 2 will give you negative 4. But the negative 2x and the positive 2x, those will cancel, leaving x squared minus 4 alone behind. Okay, those who have eyes to see know that, because they can see the reverse of difference of two squares. Take the negative 3, you distribute it inside this bracket as well. Negative times a positive, negative. 3 times 1 is 3, and then the x next to the negative 3. Negative 3 times positive 1, negative times a positive is a negative. 3 times 1 is 3. Then equal, you distribute the 1 to the x. 1 times x, 1 times negative 2. Then you transpose everything. When you transpose terms to the other side, signs change. So x, for instance, when you transpose it to its like term, it becomes negative x. Minus 4 is here, minus 3 is there, and the negative 2, when you transpose it, becomes positive 2. Okay, very good. Okay, yeah. All right, are we together, guys? Just confirm for me. Are we together? Sam is here. Good to see you, Sam, again. I see you were there at the other live, but you are here now. Thank you, Spare. Thank you, Spare, for confirming that you're here with us. Random, thank you so much for confirming you're here with us. All right. Then, like terms, guys. Okay, I'm sure. Stop like. Thank you so much for confirming you're here with us. So, like terms, simple. X squared minus 3x minus x is minus 4x. Please, guys, if you know that you butcher adding and subtracting like terms, you know you keep the variable, you add or subtract the coefficients. Negative 3 minus 1. It's funny sometimes how grade 11s you find yourself getting the wrong answer because negative 3 minus 1 becomes something else in your head. Take your calculator, punch in minus 3 minus 1 if you have to, okay? Because we don't want to be getting the standard form incorrect. Now, minus 4 minus 3 is negative 7. Negative 7 plus 2, that's negative 7 plus 2 is negative 5, equal to 0. This is the standard form of the equation. Okay? Now we are ready to do what? After standard form, we factorize. Minus means the signs are going to be different. Negative and a positive. The negative sign in the middle says the highest factor of negative 5 is going to be having the negative number. The highest factor is going to adopt the sign of the middle term, the negative number. Factors of 5 are 5 and 1. Because 5 is a prime number. Then we write x and x. Just confirm one more time. Negative 5 times 1 gives you negative 5. But if you add these two, you would get the middle term. That's what you need. Equal to 0. Standard form is fine. Zero factor law can be applied. And then finally, our answer. X is equal to 5. X is equal to negative 1. But remember, once you get your answer, you are not done. You go to your restriction. You check, is the restrictive value a value that we should not include? Because you see, you have x is equal to negative 1. That goes against the restriction. So we say x cannot be negative 1. Hadn't we written the restriction, we would have probably not seen that x cannot be negative 1. We would have just written our final answer, moved on, as if everything is fine, but it's not. So please always check, guys. You get your answer, you check against your restrictions. Do any of the values go against the restriction? All right. Okay. I hope that is a clear explanation of how we go about answering this question. I am so glad. Wow, this is such a beautiful comment. Spare, thank you so much. I was not sure how to solve this. You helped a lot. I'm glad that I helped because at the end of the day, that's what I'm seeking to do here. Okay, I know you guys are just, some of you, it's just that you forget because it's, it's been a minute. But if you can quickly revise, then you are reminded, okay, so when you do this question, look at the denominator. Step 1. Step 2, factorize if possible. Okay. No. This is not the paper you're going to write tomorrow. This is just an example of questions that you need to be familiar, that you need to know how to actually solve. I don't know what's the paper looking like that you are going to be writing tomorrow. Okay. So I don't know, guys. So please don't think I am the genie in the box and here to help you with the extra paper that you're writing tomorrow. Okay, so this is what we call fraction equations. Okay, fraction equations. You need to know how to solve fraction equations. Okay, next, look at this one. Square root of x minus 2 minus 6 over the square root of x minus 2 is equal to 1. Now we are actually coming across a question, which may look difficult, but it's so easy because we are required to solve for x, but there's something that we must see importantly, grade 11s and grade what? And grade 12s. What do you see here? A repetition of an expression. Repetitions of an expression for different terms often require us to apply something that we call the K method. Okay, I usually call it the K way. K is the way to solve for x. K is the way. We do not just solve for k and end there. We use the K way. K is the way to x. So what we are seeing here is a repetition or the appearance of square root of x minus 2 in the numerator for this term, in the denominator for this term. So to make life easy, we let k be equal to the repeated square root, which is x minus 2. What that does, it actually frees us from having to work with something complicated and working with something simplistic. So here we are. So we are going to say k in the place of square root of x minus 2. We're going to say kk minus 6 over k is equal to 1. This looks a little bit more doable. The LCD is k. So what we are going to do, since the LCD is k, and we know that k cannot be 0, we are going to multiply each term in the numerator by the LCD. So what does that do? If we multiply this by k, get k squared. Multiply that by k in the numerator, the k and the k cancel, we get minus 6. Multiply 1 by k, we get k. Then goal is to standard form. Take the k over, minus k minus 6 equal to 0. Okay, are you following so far? I'm just going to stop it right there. Okay, k, guys, is the one that can't be 0. Remember, if in the denominator we have 0, we learned something important in earlier grades, that any division by 0 means undefined. We cannot have a k value that is 0 because that will mean our equation will be undefined. So this thing called the restriction is something that prevents you and me from getting a value that will lead to there being 0 in the denominator. We want to avoid that at all costs so that we do not sabotage the equation and lead it to being undefined. So we try and play risk aversion. And what we do is we preempt, or we come to a conclusion before we even arrive at the answer as to when we get the LCD, what value in the denominator for our unknown would basically lead to there being a 0 and therefore undefined. Thank you for the rose. Black Goat Prof. Mapa Pata. Thank you so much. You are too kind. Be blessed, my son. And that sound of victory is for you. Thank you so much. Okay. Appreciate you. K squared minus k minus 6. Now we can factorize, ne? Now we can factorize. So we open two brackets. Okay. The reason why we confidently open brackets is because we can see factors of 6, which I can add, and that will give me negative 1, exist. I have negative 3 and positive 2. The multiplication of them gives me negative 6. The addition of negative 3 and 2 gives me negative 1. So it works. K is the way. K minus 3 equal to 0, or k plus 2 equal to 0. K is the way. So k is equal to 3, or k is equal to negative 2. Remember, as I said, k is the way. K is not the destination. X is the destination. So we are going to now take these k values and come and substitute them there where k is. So the square root of x minus 2 is equal to, the first k value is 3, or the square root of x minus 2, the second k value is what? Negative 2. Now guys, I want us to apply some logic here. Square root of x minus 2 is equal to 3. Is it possible to have some x value subtracted to 2 that will basically be square rooted and give me positive 3? Yes, there is a possible answer here. Look at this one, guys. Be practical. Is it possible to have some x value substituted here, after which when we take the square root, we get negative 2? Is it possible? I don't understand how we found that 3. Fumani shabangu. You don't understand how we found the 3. Fumani shabang. Fumani, come here. Come and talk to me. It doesn't help for you to be there and to just say that in the comment section. Can you speak? I just sent you an invite. You seem to have guest privileges. Let's talk. So you understand how we got to the standard form k squared minus k minus 6 is equal to 0. So does that then mean that you have a problem with factorization? Because negative 6, when the constant is negative, that basically means we are going to have different signs. So you try and find the factors of 6. 6 has the factors 6 and 1. That is a pair. But 6 and 1 doesn't work. Then you check 3 and 2. 3 and 2 is going to work. Okay, but the 3 must be negative, of course, because negative 3 plus 2 must give me the negative 1. So that's how I factorize here. Factors of 6. Okay. Yes, you could use the quadratic formula, but just remember, if you use the quadratic formula, you are going to have to be mindful of k because it's not x. Some learners make the mistake because they're so used to writing the quadratic formula as x is equal to, then they say the value here is x. They forget that they were dealing with k. They get x and then they think that they've gotten to the final answer. So please be careful there. Anyways, when you've factorized, k minus 3 is equal to 0. We are applying here what we call the zero factor law. K minus 3 equal to 0 is 1. K plus 2 is equal to 0 is the other. Then you can solve this linear equation. Take the negative 3 over, it becomes positive 3. Take the positive 2 over, it becomes negative 2. So these are the two k values. After getting k, you take the k, you go and substitute it back where you let k be. So the k is 3. Square root of x minus 2 is equal to 3. The k is also negative 2. Square root of x minus 2 is equal to negative 2. Now this side, you can go ahead and square. X minus 2 is equal to 9. We transpose the negative 2. 9 plus 2, x is equal to 11. This one, no solution. Yes, random. Random, that is the point. K is used for repetition of expressions where things may tend to be a bit complicated. There are actually a couple of scenarios where we use the K method. There's a video that I posted recently here on TikTok where I was explaining another case of repetition of an expression. And that was a situation where you could see that if we were to square this particular third equation, it was going to lead us to an equation where we have x to the power 4 as the degree of the expression or the equation. So we see that, hey, x to the power 4, we don't have skills to solve equations that have x to the power 4. So because of the repetition of the expression in that equation, we decided to use the K method because there was a repetition. That helps us to free ourselves from the x to the power 4 pressure and then apply the k method. So we can solve for k, then solve for x, and it makes life easy. So take note of the k method and where it's used. The reason why here I just say this cannot be negative, to remember there's no value of x that I can substitute, and in the square root I get -2. No ways. Okay, no ways. Darren is like, thank you so much. I'm literally writing factorizing tomorrow. I'm grade 9. And you understand that the factorization Darren is talking about is this one. And that's why in grade 9, they hammer it in. Darren, just for future note, master your factorization. It will make life easy in grade 11 and in grade 12. Many of these grade 11s that are here in the live are suffering in many solving of equations. They can't do the factorization. They rely heavily on the quadratic formula. And sometimes it's not always the easy path to take. But anyways, that's their struggle. But when you can avoid that struggle if you can master your factorization in grade 9. Okay, let's go on to the next question. So x has no solution. This 11, remember for third equations, you must check your answers. So you take the 11, you go back to the original, and you check if it works. 11 minus 2 is 9. Square root of 9 is 3. 11 minus 2 is 9. Square root of 9 is 3. So you have 6 divided by 3. That 6 divided by 3 will give you a -3. Then 11 minus 9, you had 11 minus 2, which was 11 minus 2 is 9. Square root of 9 is 3. Oh, sorry, 6 divided by 3. Sorry, that was 6 divided by 3. So that gives you 3 minus 6 divided by 3 is 2. 3 minus 2 is equal to 1. It works. It works, guys. So the 11, the x is equal to 11 works. Okay, because remember, for third equations, you must check your values of x. So x is really equal to 11. And whatever I would have gotten here, obviously we can see there's no solution because there's no ways that this could in any way give you -2. No ways, no ways, no ways at all. So I'm not going to even bother myself. Even those who would go ahead and square both sides would get your value. When you substitute it, you'll find that it doesn't work. Okay. But here, for me, the logic is clear. What value can I substitute here that will lead me to getting a negative answer? Doesn't exist. There's no such. There's no such. Okay. Let's proceed further. This question is the next one. I is to c. 2 to the power 2x plus 1. Base 2 for one term. Plus 15 times 2 to the power x. Base 2, there's another variable. Base 2, there's a variable, but it's multiplied by 2. So that means something has to give here. Okay, so let's just rephrase it. 2 to the power 2x times 2 to the power 1 plus 15 times 2 to the power x. Take the 8, bring it over 0. This is a potential quadratic. Base 2 has exponent 2x. Base 2 has exponent not 2x but 1x. So we can't take out highest common factor. Here, the 2, we rewrite this. In as much as 2 times x, it can also be x times 2. Multiplication is commutative. 2 times x is the same thing as x minus 2. But this is 2 to the power x squared plus 15. There's another 2 to the power x. See, repetition for different terms. Minus 8 is equal to 0. So let's use K method. Once again, Mr. K is coming to save the day. All right, Mr. K, because 2 to the power x in this term, 2 to the power x for that term, repetition of 2 to the power x. This is squared, this is not squared. So we are going to say 2, this 2, k, this k, because it's in the place of 2 to the power x squared. plus 15k minus 8. All right. Random. What's 2 to the power x? Remember, 2 to the power x is the same thing as 2 to the power x times 2. Multiplication is commutative, guys. 2 times x is the same thing as x times 2. Multiplication is commutative. So I just rewrote 2 to the power 2x as 2 to the power x squared. 2, I just decided to write the 2 outside the bracket instead of writing the 2 first before the coefficient, before the x. Okay, so this is just me trying to reveal the repeated expression of 2 to the power x, so that I can see, okay, this is an x squared term, this one. This one is a x term because it doesn't have exponent 2. And then this is a constant because this is quadratic in nature. The reason why it's quadratic, it's because the x here, okay, is formed by 2 times this x. So quadratic equation, potential quadratic. So I say 2k squared plus 15k minus 8. And yes, to those that say, can I use the quadratic formula? Definitely. You can use the quadratic formula to find k. Okay. It's just that some of us, we don't have time for that. You write plus 8, you write minus 1. Okay. Yeah, trial and error. Okay, but you can use quadratic formula and find the k values, guys. Just make sure that when you use the quadratic formula, the subject of the quadratic formula is going to be k, not x. Guys, always check the equation you are doing. It's like simultaneous equations. If you are getting, let's say, x and y, and let's say you use x to substitute into a y equation, and then when you get to your standard form of the y equation, you use the quadratic formula. You must be careful to make y the subject of the equation. Don't make x, because if you make x the subject, it means that in your quadratic formula you're going to solve for x instead of solving for y. So be vigilant of the main character variable that is there at the moment that you are solving. Okay, so you would say k is equal to minus b plus minus the square root of b squared minus 4ac over 2a, but you'd say k and then you'd solve for k and get the k values. You will get it if you use the quadratic formula as well. All right, 2k minus 1 equal to 0, or k plus 8 equal to 0. You solve these mostly. 2k is equal to 1, k is equal to negative 8. Here you know k is equal to 1 over 2. So 2 answers for k. Once you get your k values, you go back where? To the left part. You take the negative 8, pakati inside, half, pakati inside. You solve them independently. Alright. 2 to the power x is equal to half. 2 to the power x is equal to negative 8. Obviously this one, no solution. Okay, but this one we can write half as 2 to the power negative 1. Okay, very important. The half can be written as a base with a negative exponent. Bases are the same, you drop the base, you equate the exponents, x is equal to negative 1. So here we have no solution. Here we have x is equal to negative 1. Happiness. Oh, happy day. Oh, happy day. Oh, happy day. When Jesus was... Okay, when the mats just bowed down and said, I cannot take you and this attitude of yours of goodness, right? It's almost as if you are wanting this level 7, come hell or high water. And I was like, yeah, that's what I'm talking about. That's what I'm talking about. Okay, 1.1.7. What do we have there? Okay, guys, do we understand any questions about this K method stuff? Okay, so second question that I did using K-method, repetition of the expression. Here it was a repetition of an exponential. Okay. Okay, the reason why, let me ask you, the person who asked, why do we say x is equal to 2 to the power x is equal to negative 8? There's no solution. The reason why that is the case is because there is no value that you can substitute in the place of x, right, for a positive 2 raised to some value of x that will give you something negative. So the minute you have different signs in an exponential equation, all right, base, any base raised to a variable exponent, and then there's a different sign, meaning a negative sign on the other side, whilst this is positive. That simply means that x has no solution. NA means that x has no solution. In other words, there's no value of x that we could, 2 to the power something, base 2 is positive, and you raise it to some exponent that will give you negative 8, not going to happen. Okay, not going to happen. It's not possible. It's not feasible. Okay, no answer. Okay, NA means no answer, or not applicable, not available. All right, not available, no answer. Okay, all right, not available, no answer. Guys, this is like the same thing as, look at this. That's why, for instance, when I got here, you have the square root of x minus 2. There's a negative answer, negative numerical value on this side. And I'm trying to search for a value of x, which is going to subtract the 2, right? But it's going to be underneath the square root, and it's going to give me negative 2. Not going to happen. Okay, not going to happen, because this is an even root. So it can't happen for an even root. Okay? So that's why we say it cannot be negative 2. But even if you went ahead, guys, and you went ahead, right? Let's say some of you may have probably just been like, let's square both sides. Okay, sure. You get x minus 2 is equal to 4. Then you go ahead and say x is equal to 4 plus 2. You get x is equal to 8. You're not 8, sorry, 6. Okay, some of you would have probably done that. Okay, then you go and take the 6, right? No problem. Because the thing is that if you have a third equation, there's a responsibility on you to go and substitute the value and check if it actually works. So 6 minus 2, for instance, will give you 4. The square root of 4 is 2. Then here, 6 minus 2 is 4. Ne? The square root of 4 is going to be also 2. So it's like you have minus 6 over 2. Right? Now, 2 minus 6 divided by 2 is negative 3. 2 minus negative 3 is negative 1. But we are supposed to get positive 1. Okay? 2 minus 3 is negative 1, but we are supposed to get positive 1. So that means 6 don't work. That's why at the end we would have said x cannot be 6 anyways. Why? Because when we substitute it back into the original equation, it doesn't work. So that's why your final answer would have been just x is equal to 11. For third, don't ever forget, guys, for third equations, don't forget to check your values. Substituting, you can use your calculator quickly. You don't even have to, just choose your calculator to check if it works. Don't forget this. Third, what are third equations? These are the equations that have the square root in them. You know, those equations, when you square both sides, you always check your answers for those ones. You go back, you take your x is equal to 11, you go back to the original equation, you check if it works. You take your 6, you see in this case 6 doesn't work, which is why here I was even 100% right to actually see that it's not gonna work. So no solution. Okay, let's continue though to the next question, which needs our attention, which is 1.1.7, inequalities. Hello, inequality. I hope you are well. Inequality, how are you, quality? Okay, Guys, we are facing currently a lot of inequality in the world. Okay. Race, xenophobia, you call it what you want. Okay, just life in and of itself is not equal. Things are not equal. You know, some people are more privileged than others, you know, less privileged. So there's no equality, there's inequality. All right, some are greater than others, some are less than others, you know. Yeah, in wealth, in status, in marks, even at school, in class, everywhere. Anyways, x squared minus 5x minus 6 greater than 0. Okay, so first step, equation, you know more, so we check standard form, check. Next step, factorize. So I'm going to do next step, factorize, open 2 brackets, factors. Guys, minus means different signs. So I know I'm going to have a negative and a positive. Then the highest factor, according to the minus in the middle, is going to have a negative sign. So we look at factors of 6. When we multiply, they must give us negative 6. When we add, must give us negative 5. So 3 and 2 is not going to work. Okay, very good random. 6, 1. Who is this person? BK, wrong timing. Do this on Thursday. No, BK, when you have the wrong understanding as to why I'm doing this. I have grade 11s that are writing tomorrow, paper 1. Never mind the grade 12s that are writing paper 1 on Friday. So it's not wrong timing, it's just wrong timing for you. Okay, don't be so selfish. You are thinking of yourself alone, not of other people. That's why you are saying what you are saying. CV, critical value. Remember, critical values are roots or x-intercepts. So in other words, it's like we are writing the values where we are solving. Mariana Erasmus, you're writing tomorrow. Grade what? Grade 11, grade 12? Critical values, x is equal to 6 or x is equal to negative 1. Critical values, guys, are like our roots. Okay, if we were solving for x. Haibo, Mariana Erasmus, grade 12. How are you writing tomorrow, grade 12? Oh, different province. Different province. Are you doing IEB or CAPS, dear? Then, graphical representation. Graphical representation. Small critical value. That's why I'm saying critical value is an x-intercept or it is a root. Okay. Small critical value, big. Then we interpret this. What does greater than 0 mean? It means where y is positive. Where is y positive? Above your x-axis. Greater than 0 means where y is positive. Where is y positive? Above the x-axis. So it would mean this region. This is the region where the answer lies. It's on this side of negative 1, which means x is less than negative 1. And it's on this side of positive 6, which means x is greater than 6. That's where the function is above the x-axis. So in other words, that's where y is positive. X less than negative 1 or x greater than positive 6. Is that hard, guys? So this inequality thing requires us to factorize after standard form, write down the critical values, graphical representation, answer for 2 marks. The gist of the baby is here. Critical values, factors, our graphical representation. Okay, now I know the mark allocation doesn't say so, but you want to have all of these aspects represented as part of your answer for your inequality, so that even if the teacher is like checking you and he's like, no, you know everything is right. Leighton, can you help me out with my life goal there? 10 galaxies before I go to sleep. Or not 10 galaxies, Leighton, but like 5 money guns. Yeah, guess the day is coming here. Yeah, we just better believe it. Just like you better believe that your level 7 is coming. Okay, let's move on. 3x minus x squared greater than or equal to 0. Okay. Listen, Ashley Mack, take note of the next question. I'll tell you, because this one will require what you are asking about. Okay? This will tell you the next question. Okay? So 1.1.7 was that one. 1.1.8 we are busy with now. 3x minus x squared. Take note of the next question because you asked the question, very important. Okay, this one is not included, so that's why we said less than -1, x greater than 6, because there's no equal sign. Okay, no equal sign. You could write this answer in interval notation, which is you'd write minus infinity to -1, open, open, or this u means or, it means union. You could write from 6 to infinity. This is another way of writing this answer. Okay, interval notation if you want. It's not a must, but some people tend to want to write the answer here in interval notation because it shows from -infinity to -1, but it's not included, open bracket, and then or from 6 to infinity. Let's look at this question. Someone asked, when do they know when the inequality sign changes? Please take note of this. This expression on the left has an x term and it has an x squared term. All right, so now what you do, you seek to first make the equation, you write it in standard form in the order. But now you want to do what? You are going to take out the what? The highest common factor, which is what? -x. Okay, but maybe what we can do first, because the negative sign is at the variable with the highest exponent, let's divide by a negative. So when we do so, this becomes x squared minus 3x. When you divide by a negative, the inequality sign changes direction at that very moment. So the person was asking, when does the inequality sign change direction? It changes direction when you divide by a negative, left and right. So you can see we divided by the negative coefficient, -1. We divide by negative here, this changes to positive, changes to negative. The inequality sign will change direction at that very moment when your division of negative happens. Okay, so the person was asking the question, when does the inequality sign change? Are you answered? This was Ashley Mack. Ashley Mack, are you still around? Are you answered? Do you feel satisfied in your understanding now? Oh man, that's so beautiful. That is a magical moment. That's why that sound. One more time. Awesome. Okay, now we take out Mr. Highest common factor, which is x. Okay, then critical values. After factorizing, this was the standard formula. After factorizing, we write the critical values. X is equal to 0 or x is equal to, for the bracket, 3. Ne? Then graphical representation. Okay, and this is on the basis of the standard form with the a value that is positive. So my graphical representation is I always personally always draw my graphical representation of the function on the basis of my standard form where the coefficient of x squared is what? Is positive, so that I judge that graph based on this inequality sign. Okay, I judge my graph based on this inequality sign because my drawing is directly related to this standard form that has a coefficient of x squared that is positive. Smiley face, a is positive, smiley face, that's why. Okay, smallest critical value 0, biggest critical value is 3. Okay, then judging by the less than or equal to 0, what does that mean? The less than part 0 means y is negative. Y is negative. That means below the x-axis. We know most on the Cartesian plane, y is negative where? Below. Very good, random. Random, you are not so random after all. Below the x-axis, that's where y is negative. So this is the region. This region. The region that's between the critical values. Okay, then the equal means on the x-axis. Negative y means below the x-axis. Equal means on the x-axis. So we are looking at on the x-axis, meaning we are including the critical values. So when you write the answer, x in the middle, greater than or equal to 0, less than or equal to 3. You can write the answer that way, or people choose to write it in interval notation. X is an element, square bracket, 0 to what? To 3 square brackets. That's also fine. Okay? Are we together, guys? But you see, you need to look at what they said in the statement of the question. This is not where we end. We would think that's where we end, but that's not where we end. The question says, where x is an element of natural numbers. So they want the values of x where x is an element of natural numbers. So if we look at this interval where the answer lies, right, we need to then go and say x is an element, curly brackets. We identify the natural numbers that are between 0 and 3. 0 included, if it's a natural number, we would list it. To 3 included, if we are also talking about. So what are those, guys? What are the natural numbers between 0 and 3? Guys, this is not a past paper. This is just a practice, okay, paper. It's not a past paper, it's a practice paper. Okay, it's just there to test your knowledge of grade 11 for some of the topics that you have covered. Okay, last night I was here doing another paper, which was a practice paper. It was not a paper that's been written in an official exam, you know, in one of the provinces. You know, it's just good practice papers. Random says 1, 2, 3, and random is correct. Natural numbers are numbers that start at 1. So 0 we cannot write here because 0 is a whole number. But natural numbers are numbers that start at 1. They increase by 1 all the way to infinity. So in this interval, we can write 1, 2, and 3 inside the curly brackets, and we list them. This is how you write the answer, and that's where the thing ends. Okay. But why did we end up having to write that answer? After identifying the interval of the values where this inequality can be satisfied, we had to identify the natural numbers that lie in that interval. Okay, 0 is not there because 0 is not a natural number. But the one natural number that follows after 0 is 1. Then 2, still within there. 3 is also because it's an included value. And that's it, full stop. So this would be a key mark here. Key mark. Right? Key mark. Very key. Change of the inequality sign, very key. Standard form and critical values, very key. Okay. And then of course you want to see your graphical representation. Okay. I hope that makes sense, guys, and I hope you can appreciate, you know, what we are doing here. The reason why I had to write this is we were told that x is an element of natural numbers. If we don't know what natural numbers is, that's where the cookie would crumble. Yes, random, you can use the number line method, that's also fine. I just obviously am a I'm a very avid fan of the graphical representation because it lays the foundation for functions. And functions is basically a topic that, you know, yeah, if we are familiar with that way, it makes life very easy. Right, I'm gonna give you guys a chance to do this one because I know you know how to do it. Okay. Solve for x and y. You should be able to do this one. Okay, 3x plus y is equal to 5. Solve for x and y. Okay, before we go to nature of roots and stuff and functions, but like it's, yeah, do that. I'll give you 4 minutes. We know most simultaneous equations, the drill. Yeah, I'm sure you guys are done and finished. We take one equation, in this situation, the linear one, okay? We know obviously simultaneous equations are not limited to just these types of equations. There are other ones, né? But when given these ones, we make sure that, yeah, we isolate one of the variables, make it the subject. So if we say, for instance, made x here the subject, that means x is equal to 5 minus y. That's going to be equation 3. That's equation 1 already. That's equation 2 already. And already, just by doing this, 1 mark is awarded you because you made x or y the subject. You take this expression, you substitute it everywhere where x is. So 5 minus y will be substituted there times y. Okay, but we know y must and 5 minus y are multiplied. So multiplication is commutative. So I can put y this side or put y that side. I just need to remember that we are going to, at the end, distribute the y because it's a monomial by binomial. Had you put y this side, you would have just had to remember that you're distributing it. So it's always safer to put the y on the left because you are so familiar with distribution when things are on the left. 21 minus x in the place of x, 5 minus y. Then you square it minus y squared. Second mark comes because of your substitution of x. 5 minus y in the place of x. You multiply out y times 5 is 5y, y minus y squared. 21 minus this one, we know most, 5 minus y squared. Square the first term, square the last term, product of the two, negative 5y, and you double it or times it by 2. So you have negative 10y plus y squared, né? Minus y squared. 5y minus y squared is equal to 21. You distribute the negative sign, take it in to all 3 terms. Very important, that one. Take that negative sign inside all 3 terms. So you have negative 25 plus 10y minus y squared minus this y squared. Like terms can work at this stage. Okay, so let's take everything over. Negative y squared, this one. The 2 y squareds are these ones. We took them over. Ne? Yeah. 5y, that 5y. Negative 10y, we took it over, it's negative 10y. Doing negative 25 took it over, it's positive 21. 21 took it over, it's negative 21. The addition of the y squareds leaves me with y squared. That is positive. 5y minus 10y is negative 5y. Then 25 minus 21 is 4. Okay, positive means same signs. That's what positive means. Okay, so you simplify to standard form. There's usually a mark for simplification here because multiplying out, transposing, that's a mark that you get there. And then the standard form is another mark. So positive for your constant when the coefficient of the y squared term is 1 means same signs. Same signs according to who? It's always the same signs according to the middle term. So when I open my brackets, I write the same signs, but they are both negative. So if the positive was there, I would say same signs according to the middle, it would be positive, positive. But since it's negative, it's same signs according to who? This one, negative, negative. Vectors, we have 4 and 1. That works because the multiplication gives me positive 4. The addition of negative 4 and minus 1 gives me negative 5. I have y and y. So 0 factorial of y minus 4 is equal to 0, or y minus 1 equal to 0. You get your y values. Y is equal to 4 or y is equal to 1. You take these y values. Okay, so standard form factors the y values. Ne? Why don't you use calculator? Guys, I just love my head. I love my head. Guys, the sharper, I guess the thing is, the more something is used, the sharper it becomes. So I don't personally like using the calculator. And secondly, to be honest, I love sharpening my mind. All right. I feel like I'm still young. So I need to actually make sure that I'm alert and I use my head. Okay. Okay, so using my head makes sure that I can see things. But if I'm going to use the calculator too much, I'll rely on the calculator and then I'll become mentally lazy. I understand that, Shanik. Okay, I understand. And when you do, use it because, yeah, use it. I mean, don't mind me. Don't mind me, okay? Don't mind me. All right, yes. Time is of the essence, Shanik. So I mean, I respect you for that, okay? And that's judgment, good judgment that you're using. So let's take then the y values, we substitute them back into the equation 3. We set up this equation for that purpose. So it's like x is waiting to have fun with the y values. So 5 minus 4, which is the first y value there, or x is equal to 5 minus 1. X is equal to 1, or x is equal to 4. The second x values, you get a mark for that. Then, I mean, guys, what a beautiful way than to say x is equal to 1 when, x is equal to 1 when y is equal to 4. X is equal to 4 when y is equal to 1. I tend to want to write those. Can I ask, why don't we show the marker of the examiner which one is equation 1 and equation 2? No, you do that. Remember, I did say that I said it by head that that's equation 1, that's equation 2. You would show the marker, of course, but it's just that I was just showing you that, you see, I'm continuing taking equation 1, making it equation 3. So please do that. Okay, that's a good contribution, by the way. Okay, I was just showing you that I'm continuing on, take that equation, make it equation 3, and then that's why I marked it. Okay. No problem, Shongwe. Very good contribution there. Okay, let's move now to nature of roots. I'd love to join every single time. Shanique is like, I'd like to join every single time. You're kind. That means you enjoy the company. You enjoy the mathematics and the company, Shanique. I suppose you guys are finding me live for the first time. You would know if you were joining every once in a while in the evenings. I tend to dedicate the evening time from 10:30. I would sometimes, but it's not every day, guys. I must say, it's just that sometimes other commitments pull in a different direction. If you guys would be, I don't know, I almost feel like if you guys could find people that could give me a reason to actually always come on here, okay? Because obviously this is time spent. So maybe if you guys can amass, let's say, your parents and just tell them, guys, just can you just, it's like, Mom, can you just join this guy's live and just gift him, for crying out loud? Mommy has the money, right? And daddy and all your uncles and stuff, share the live with your uncles, and then you can just like, just let it roll on this guy, let it rip. That will, I'm telling you, that will buy my heart. I'm such a gift. Yeah, that's my love language. So then I will make time, I'll avail myself more consistently, because I won't have reason to want to dedicate my time in other things, if that makes sense, during these times. But it's just that there are other things that pull for my attention. That's why I'm saying, yeah, I love doing this and I love helping you guys. Without solving the equation 3x squared plus 8x minus 2 is equal to 0, discuss the nature of roots. Discuss the nature of roots. So it's not like they want you to get into a discussion, but it's just that there's a way in which you discuss the nature of roots. The way that you do so is you use Mr. Discriminant. This is where the way you discuss the nature of roots. You write down the discriminant. If the equation in standard form, you identify your a value, which is 3, b, which is 8, c, which is -2. That's how you discuss. You take the a, you substitute b, a, c. 8 squared, 64. 4 times 3 is 12, 12 times 2 is 24. The negatives, positive, negative leads to positive. So 4 times 3 is 12, 12 times 2 is 24. This is 88. Delta is 88. So 2 things. Delta is greater than 0. That's the first thing. Secondly, delta is not a perfect square. The number 88 is not a perfect square number. Perfect square numbers are like numbers like 1, 4, 9, 16, 25, okay, and so forth. Okay. Remember, when they say without solving the equation, they say discuss the nature of roots. This is what you mean. This statement that says without solving the equation is simply saying use the discriminant. Delta is equal to b squared minus 4ac. Okay, you substitute your a, b, and c from the standard form equation. You must make sure the equation is standard form first. Identify a, b, and c. You substitute, you get delta. This value, like I said, is greater than 0 firstly. Secondly, it's not a perfect square. So what conclusion can you make? From this, you say that the roots are real. That's what you get from greater than 0. 2, unequal. That's what you get from greater than 0. 2 things, real and unequal. And from not a perfect square, you get irrational. Roots are real, unequal because of delta being greater than 0. The roots are irrational from the fact that delta is not a perfect square. If delta was a perfect square, you wouldn't say the roots are irrational, you would say the roots are rational. Okay. I hope that makes sense, guys. Hope that makes sense. So this is how you discuss. How many marks? 5 marks. Beautiful discussion. Are you happy? Content with the discussion, guys? Okay, hope you're happy with the discussion. When do I do calculus? Shanique, when do you need me to do calculus? Because after tomorrow, I think maybe tonight, no, actually tomorrow night, I can probably take on calculus. If you come bearing gifts, I'll definitely do calculus. Or you're writing next week Friday. Okay, let's maybe save it up for the weekend then, because I want to wrap off helping some of the other grade 11s, which I know will be writing in the weekend as well. Okay, but I'll definitely make some time to do calculus. I've done calculus in the past in these live lessons. So for instance, the last thing I had done, which was calculus related, I think it was 2 nights or 3 nights ago, I did cubic functions. And we were doing exam type questions because I'd gone through the theory of cubic functions. And we were doing, the last thing I did was optimization, actually. Wow, forgot that. So we started optimization, looked at what it is, and then we were doing some word problems on optimization. Not the measurement, surface area type questions, but just the others that have to do with motion, calculus of motion. Anyways, that's that. Let's look at this one. Show that the roots of the equation. So this question and this one are done the same way, in that we say discriminant identify A, B, and C from the standard form. 3. Thank you for the rose, Shanique. Sorry, I didn't see that. Thank you for the rose, Shanique. Really appreciate you. So discriminant, identify ABC from the standard form. Get a value of delta. Judge delta. And then conclude about the roots from delta or from the discriminant. So that's basically what we do step by step. This is the step-by-step. Okay. So I would say probably we must make sure first the equation in standard form, because we can't, when the equation is not in standard form, identify A, B, and C. So the discriminant can only be populated with the right values if the equation is in the form ax squared plus bx plus c equal to 0. Then we can identify A, B, C, substitute into the discriminant, get the value of delta, judge delta as to what condition it is in, and then be able to describe the roots from delta. Okay, let's look at 2.2. Show that the roots of the equation are non-real if m cannot be 0. This question is done the same way as that one. It's just that instead of delta being a value, we are going to get delta as an expression. So I repeat again. This question that says show that or prove that is done the same way as the question above. So check what I'm going to do. You see this equation? I'm going to write it down. X into x minus 3m is equal to negative 5m squared. Okay. Then let us take this equation. Make sure first that it is standard form. It's not in standard form, so let's make it to be so. Take the x, distribute it. We get x squared minus 3mx. You take the negative 5m over. You get plus 5m squared is equal to 0. So what do you see here? Standard form. This is what we want. When we started off this question, it was already in standard form. That's why you saw me jump into the discriminant. But first, now here, we need to prepare our equation so that it is first in standard form. BVV Sikakane, thank you for sharing the live. You shared it quite hectically. I wonder who are you sharing the live to? So many people you shared the live to. Or are you sharing it to groups? You're trusting too much what's happening in this live? Okay, that's the standard form, guys. Okay, then when we are here at this stage, what do we do next? We actually now can identify A, B, and C. So A here is 1. B here. Can someone tell me what B is? I want to see if you guys can see. What is the value of B and what is the value of C? What's the value of B? What's the value of C? I'm interested to know from you guys. Random says negative 3m is the value of B. Jack says the same. Gigi, Trufi, and Shongwe, be careful, it's not positive 3m. Remember, when you identify the coefficient of an x term, you take its sign and the number, okay? And then m as well is put as the represented coefficient, because when we say the coefficient of x, it is actually everything multiplied to x. All right, then here C, very good, Jack. C is equal to 5m squared. So do you see why I'm saying this show that question that we have here is actually done the same way as this one, but our delta value is not going to be a number. Our delta value is going to be an expression in terms of m. Now that we have identified A, B, and C, we can deltarize. Substitute b squared in brackets negative 3m squared minus 4. For what? For A. A is 1. C, 5m squared in brackets. Then negative 3m squared, we get 9m squared, because remember, an even exponent applied to a negative sign is positive. Any even exponent applied to a negative sign leads to a positive sign. 3 squared is 9. M is m squared. Minus 4 times 1 is 4 times 5 is 20. M squared attached. What are these? Like terms. What's the answer? Negative 11 m squared. That is delta. Do you see that delta is not just a numerical value, but it is an expression in terms of m. Let's go look. What did they say we need to show? Show that the roots of the equation are what? Are non-real if m cannot be 0. Let's check this out. If m is not 0, remember, if m is 0, 0 squared will lead to 0, and 0 times negative 11 will mean that delta is equal to 0. So they are saying m cannot be 0. If m cannot be 0, it means any other m value, all right, that you substitute here will basically lead us to an m that is positive. Anything that you square, all right, any value that you will put in here that is not 0, if you square it, it will be positive. Okay, if you square it, it will be positive. But then that positive multiplied by any negative number will lead to a negative what? It leads to a negative number. Does that make sense, guys? So that then means that delta is going to be negative. Does that make sense, guys? Delta will be negative. And if delta is negative, what do we know? Firstly, we'll say delta is less than 0. Delta will always be less than 0 if m cannot be 0. So what does that mean about the roots? The roots are non-real as long as our m cannot be 0. Does that make sense, guys? So we have proved it, that indeed the roots of the equation are non-real if m cannot be 0. We've proven that because as long as m is not 0, any number you square will be positive. Multiplied by a negative number, it will always be negative. That's why we conclude that delta cannot be 0. I mean, delta is less than 0 if m cannot be 0. Therefore, what do we know about the roots on the basis of this? The roots are non-real. Finished. So that's why I was saying you answer show that and prove that the same way you would answer discuss or determine the nature of roots. Okay. Jennifer, really? My goodness. Hey, Jennifer. Jennifer, I didn't even know that. You are really surprising. I didn't know that. Congrats. I didn't know that. So that means that is, we can just say all glory be to God. You watched all those late nights. Oh my goodness. DM me and let me know what you're doing with your life at the present moment. My goodness, I can only pray that God blesses you immensely in everything that you do. Oh my goodness. Oh, wow. I didn't know that. I didn't know. I guess there's probably a lot of Jennifers that I don't even know about, because I guess we never talked and no one ever said anything. But I'm happy for you, Jennifer. I hope life is treating you well. Okay, guys, look at this next question. Consider the quadratic equation. Don't guys, I did simultaneous. Just came from there. Literally. Like I did. You see, we are a nature of roots now. I was just here not so long ago. Okay, talking about this question. All right, let me just maybe just give you a linear equation and a quadratic. Why do we say this is linear? Because the exponents are both, for x and y, they are 1. Why do we say this is quadratic? Because it's got some variables that have exponent 2. So you take the linear equation. That's what you always do. You take the linear equation, you either make x or y the subject. So we chose to make x the subject because the coefficient of x is 1. We transpose the y, so it's 5 minus y. First mark that we get is actually making x or y the subject in the linear equation. Step 2, you substitute the 5 minus y everywhere where you see what? X in the other equation that you did not touch. So in the place of x, we are going to substitute 5 minus y. The x and the y are multiplied. So we can say y times the 5 minus y in brackets equal 21 minus the x squared. We substitute 5 minus y. We square it. Minus y squared minus y squared. Second mark for substitution in the other equation. Are you following so far? Father's daughter. Father's daughter. Are you following so far? Father's daughter. Okay, then father's daughter. You take the y, you substitute, you distribute 1 time y times 5, 5y. Y times negative y squared. Okay, equal 21 minus. This is 5 minus y. You can open 2 brackets most of 5 minus y and you FOIL. But the shortcut, if you are in grade 12 and 11, because in grade 10 you learned about the binomial squared, you square the first term, you get 25. You know that there's going to be 3 terms from this. You square the first term, it's 25. You square the last term to get the last term in the bracket. Negative y squared is y squared. Then what do? You multiply 5 and negative y. You get negative 5y. You double the answer. I repeat, the product of 5 and negative y for the middle term. You will get negative 5y. Then you double, you twice that negative 5y. You get negative 10y. That's for the middle term. So now you have the 3 terms that you need for this bracket. You keep the bracket until you can take the negative sign and chwa, 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 chwa. All 3 terms. Negative y squared is there at the end. Okay? Then, after you've chwad, negative times positive, negative. Negative times negative, positive. Negative times positive, negative. Then you transpose your negative y squared. Your negative y squared this side, you transpose it to join, it becomes positive. That one, positive. 5y is already positive this side. You take the 10y, it goes over negative 10y. You take the 21 over, becomes negative 21. You take the negative 25 over, becomes positive 25. You add the like terms. You get your standard form of the equation. Are we together so far? Father's daughter. Father's daughter. Daughter of the fathers. Yebo. Okay, then daughter of the father. Y squared minus 5y plus 4 is what you get when you have added all the like terms. Because negative y squared plus y squared plus y squared gives you y squared. Y squared plus y squared, 2y squared. 2y squared minus y squared, give y squared. 5y minus 10y, give negative 5y. 25 minus 21, give positive 4. I can hear father's daughter, it's like you are free to go home. Constant is positive, negative 5y. Positive means same signs according to who? According to the sign of the middle term. So positive, same signs. That's what it means. Same signs according to the sign of the middle term. Negative, negative, you find the factors of 4. 4 and 1. When you multiply, you get positive, or when you add them, you get negative 5. Then y and y gives you y squared. Then you take y minus 4, you equate to 0. Or y minus 1, you equate to 0. You find the y value. You transpose the negative 4, you have positive 4. Transpose the negative 1, you have positive 1. Then, what do you do when you are here? You take all these y values. You had prepared equation 3. Why did you prepare equation 3? Because equation 3 was going to help substitute the values of y that you got. So you take those and you substitute them here. Okay? 5, 5, minus, minus. In the place of y, you put the 4. 5 minus 4, chua, x is equal to 1. Again, take the 1. X, equal, 5, 5, minus, minus, chua, in the place of y, 1. 5 minus 4 is 1. 5 minus 1 is 4. So when x is 1, y is 4. Remember, again, these are what? Point of intersections. These are the points where the line and its quadratic, whatever, they intersect. They intersect at these 2 points. So when x is 1, y is 4. When x is 4, y is 1. Hope you are helped. That is just a Makabanchinchi of simultaneous equation. Father's daughter, are you fathered? Do you feel fathered? All right, awesome. Good job. Great job to you. Let's come here. Consider the quadratic equation. Kx squared minus kx is equal to 2. Show that the roots of the equation will equal that. So here they are saying show that the roots. What are roots? Roots are simply the solutions of a given equation. So we are given kx squared minus kx equal to 2. We are going to transpose that 2 so that we can get the equation to be in standard form. So far, that is the standard form of the equation. We're going to use the quadratic formula to solve for what? For x. What are the solutions of this equation called mathematically? They are called roots. So they want us to show that this is the solution we get at the end if we solve this thing. Okay, and the only way we can solve it is basically to use the quadratic formula. A value, our a value, what is a here? What is b? What is c? What is a? What is b? What is c? What is a? What is b? What is c? What is a? A is equal to k. Very good. The coefficient of x squared. B. Very good. Negative k. What is c? C is negative 2. Let's not forget the sign, guys. The coefficient of x is negative k, so it has to be negative. Then we go to the quadratic formula. X is equal to minus b plus minus b squared minus 4ac over 2a minus b minus what b? B is negative k plus minus the square root of what? B squared negative k squared minus 4 what? A is k, c is negative 2. Let's drag the square root so that it actually covers everything there at the end. Over 2a over 2a is k. God, imagine if you had this amount, 2k. The things you would do. Oh man. Okay, negative times a negative. That is k. Plus minus e square root into negative k squared. We apply the exponent 2 to the negative sign, it becomes positive. Apply the exponent 2 to the 2k squared. Okay. Did I just rejoined? Did you transpose to get standard form? Yes. I took that. Yes, I transposed because I can't use the quadratic formula until I have the equation in standard form. Standard form obviously means you have the equation in the form ax squared plus bx plus c is equal to 0. So I had to transpose the 2 to get the standard form. And then I get a, b, c. Guys, standard form is this. The standard form of a quadratic equation is ax squared plus bx plus c equal to 0. Yeah? Okay? Alright? Alright? Are you feeling me, brothers and sisters? Can I get an amen in the comment section? Can I get an amen in the comment section as we cross over from one day to the other? Dear Lord, be with those grade 11s and grade 12s. May their hearts not be discouraged. May they not be discouraged. Give them the strength to be able to persevere, persist. This is their dream. Be with them. Be over them, watch over them, be with their minds, be with their hearts, let them not be discouraged. Will you also just disperse and dispel any powers or sources of darkness and discouragement, despondency, any anxiety, anything, dear Lord? And I mean, this is no joke, guys, but may the peace of the Lord rest upon you. The joy of the Lord be your strength. Okay, so -4 times k. -4 times k times -2, that's positive 8k. All right. Okay, so you take a peep, you're like, oh, look what's happening. Look. You see, -4 times k times -2. It's materializing. Look at it. Look here. K. Oh, it's negative times negative. Look at that. It's k plus minus the square root of k squared plus 8k. It's happening. 2 times k is 2k. These are the roots, guys. I got it. We got it, guys. Show that the roots of the equation will equal. We've just showed it. Show them. We've showed them. Okay, so we've showed them, guys. Okay, now determine the numerical values of the roots if k is equal to 1. Take note of the wording. Determine the numerical. These ones were the roots in terms of k. Now they want the numerical values. They actually want these values so that we get the actual values. So we are going to come, write equal, say x is equal to, they want the numericals values if k is equal to 1. So let's go ahead and substitute there for the next question. 1 plus minus 1 squared plus 8 into 1 over 2 times 1. Okay, let's get it. 1 plus minus square root of 1 plus 8 over 2. Then we get 1 plus minus square root of 1 plus 8 is 9. The square root of 9 is 3 over 2. Grand finale, finalize it. So we have 1 plus 3, which is 4 over 2. That's one of the x values, or x is equal to 1 minus 3, which is basically -2 over 2. The two x values numerically are 2 or x is equal to -1. That's it. That is how we get them x values. The numerical, you see. If k is equal to 1, that's a basic substitution question. You would expect that that if they said k is equal to 1, it means you substitute. You can substitute in the roots. Some people would have decided to go back to the original equation, substitute in the place of k1, and then solve the equation from here. I mean, that would be fine as well. It's no different, okay? It's no different, okay? So this is like a hence approach, hence use the answer to get the value of x, or you could basically go back to the original equation, all right, which is not a hence, it's otherwise. You know how sometimes they say in a question, hence or otherwise, find the numerical value of the root. Okay, so basically that's what you would, yeah, I hope we are good. Then look at this question. Determine the values of k for which the roots are equal. What would you do here, guys? They say determine the values of k for which the roots are equal. Question that needs you to wise up and look. If they are saying, yes, random, dear random. Whoop. This is random. My guy, delta. So can you guys tell me what the expression of delta is? Because it is actually here. It is there. Look at it. Where is it? Can someone tell me what the expression of delta is? You should be able to see it. Okay? Random, I see what you are saying. But can you see it? Can you see it? The actual expression. It's already in terms of k. Yes, random. Random. Yeah, random. That's it. K squared plus 8k, my guy. Yeah, random. Random is on some other level. Guys, this here, remember, is where b squared minus 4ac would be. These are the roots of the equation in terms of k, and where this is where delta is actually situated. So we can actually now harvest. What do? We harvest the expression k squared plus 8k, and we do what with it? Well, we harvest it with the purpose of saying delta is equal to k squared plus 8k. All right, but then they said determine the values of k for which the roots are what? Are equal. So for equal roots, what does that mean for delta? For equal roots, that's a condition. What does equal roots mean for delta? For equal roots, delta is, yes, Matatela. Whoa, Matela was here yesterday. Matela, didn't you write today? Matela and random. Very good, guys. Very good. Okay, sorry, guys. Very quickly, I want to do this. Boom, gone. Okay. Block. You wrote today, buddy boy. How did it go? You guys, Matela, do you guys know that I actually was late at work yesterday, because of the late night slept 3. Didn't hear my alarm. Woke up very late. Ended up going to work quite late, and it was just crazy. So yeah, I'm hoping today it won't happen. Yes, guys, you're right. For equal roots, delta is equal to 0. So then we're going to take the expression k squared plus 8k. We equate it to 0. Guys, for questions like this, these are very common questions. Determine the values of k for which the roots are a certain way. Let's say this question had said, determine the values of k for which the roots are non-real. Then we would have done the same thing. Harvest the expression of delta, then ask ourselves, what does for non-real roots mean? Okay, if this condition here was non-real roots, then we would have asked, what does it mean for non-real roots? Yes, random. It means delta is negative. In other words, delta is less than 0. Then we would have set up an equation, which is an inequality in actual fact. We would say k squared plus 8k is less than 0. That would be a quadratic inequality. We would have to solve it the very same way that we are used to solving a quadratic inequality, which is basically, what do? Standard form, we factorize, critical values, graphical representation, answer. Standard form, factorize, graphical representation, answer. Standard form, factorize, critical values, graphical representation, answer. Standard form, factorize, critical values, graphical representation, answer. So And let's say they had said for which the roots are real. For which the roots are real, then we would have said delta is greater than or equal to 0. So the condition would have been k squared plus 8k greater than or equal to 0. So what I'm saying is these questions are also of great importance. Remember, guys, if we did not have this, we would have had to first find the expression of delta by saying delta is equal to b squared minus 4ac, and then we would have been able to just get delta on its own. Okay, but if the roots are given, we harvest delta underneath the square root. Let's never forget that. Okay, let's solve, guys. I'm sorry, I'm speaking too much. K into k plus 8 is equal to 0. K is equal to 0, or k is equal to negative 8. Determine the values of k. The values of k are k is equal to 0, or k is equal to negative 8. Boo, 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 boo. Boo, 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 boo. Okay. And who would have thought? Just like that. Okay, guys, I'm just going to see, just by inspection. These are exponents, no? These are exponents. I hope that we can see how we simplify exponents, because remember, exponents and surds, these are also part and parcel. Hopefully we can see what it is that we need to do there. Simplify without using a calculator. We've got 81 there. Okay. Right. Yeah. Very various and different ways. Right. I'm sure some of you are like many different and various. So in 3.1.2, when we have a minus in between, if we look at the base 2, it's raised to the power n. This base 2 is raised to the power n. But we have a plus and a minus in between. What is the procedure? Hopefully we are very much aware. Hey, look at this one. Very interesting, that question. Okay, simplification there. Okay, all right. Well, look at that one. Express if root 2 is equal to a and the root 3 is equal to b. Express the following in terms of a and b. Square root of 108 minus the square root of 18. Okay, it's just like a snapshot, sneak preview to some questions that are exponents related. These are not limited to all. This is just some. All right. Okay. And then there's a nice show that kind of question as well, that the square root of a minus 2 plus 1 over a can be written as that. Okay. I'm not going to answer those questions. I'm just sort of like saying, well, exponents, guys, let's not forget the exponents as well, and your surds. Okay, there's those questions for surds as well that have to do with writing a, like for instance, the square root of 75, writing a number, like for instance here, writing a number, a perfect square number and another number, and being able to basically express those as such. Okay. McPhee is saying it's blurry. Is it blurry all around, guys? Can't you see a thing? Oh my soul. Okay, because I feel like everybody's like functions. So I'm actually going to now put a pause here on this and not do the questions. I mean, this is just for your own perusal. You can always there's more questions to exponents and surds than just these. We just need to know our exponential laws, and we also need to know the surd laws and know how to express a exponential to a surd form to exponential, root form to exponential to root form. So that also is able to serve as well. Okay. So guys, give me the right to leave this section so that we can actually look at functions. Is that correct? because yeah, like for these grade 11s, they need to know them functions. Okay, let me leave this then. And let's see if we can't do the royal pursuit of functions. Yeah. Exponents, guys. Exponents. Very key, like section. Very key section. Very key section. Very key section. Yeah. I'm just thinking in light of function. I mean, of exponents. Here's something else to kind of like be aware of or mindful of. You know, like yeah. You see, exponents. You can see most exponents. The difference between when you have multiply and divide alone, which is like where you just convert your composite bases to prime bases, and then after doing so, you multiply the exponents, and then you collect same bases, and you apply law number 1 and 2 of exponents, and you simplify, as opposed to when there's addition and subtraction in between. You know, yeah, exponential equations, of course, right? Very key as well. Exponential equations, very key. Very key. Exponential equations, very key. Okay. And then I'm crossing over here this side. Exponential equation. Okay. Yeah. So these are just varying different types of questions. Yeah. All right. Just giving you like a kind of another snapshot of other types of questions for exponents. Okay. Now I'm just needing to actually go and do themselves. And then X functions. Right, just give me a sec. Jingle bell, jingle bell, jingle bell rock. Da 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 da. Ba ba da ba. Bum bum bum. Bum 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 bum. Yes. Grade 11 indeed. Okay, we were pulling the midnight oil. Welcome to the pulling of the midnight oil. Yeah, I wish I could. Yes, I do. Don't worry, I actually do, Shy, but it's just that it's the grade 11s right now that are like, ask them why they don't want me to sleep, because I should be, but they have me on a tailspin. I think I've got it bad for them, eh? You got it bad. When you come round back. You got it bad. I think I've got it bad for the learners here. It's insane. I think I got it bad for these learners. I don't know what's happening to my. I'm trying to sleep. I've got it bad, but I can't seem to let go of helping them out. I don't know what's up. I've got it bad. 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 Okay. The only problem here is that this is a mix of both. Yeah, you see. But let's do the ones that relate to parabola. And I know that there's a specific focus on parabola and straight. Yeah, I think I got it. Okay, can I just have you guys write down the coordinates of the turning point of f? F of x is equal to f of x is equal to 4 minus x, 4 minus into x plus 2, the whole thing squared. Write down the coordinates of the turning point of f. Okay, I think we can definitely answer these questions related to the parabola, right? Because of the question limitation that we have. Can I just check, is everybody having the limitation of having to do parabola and straight line alone and not any other function? Or are others actually for grade 11? I'm talking about grade 11 specifically. Or are we all under the all functions, you know, all functions for paper 1, grade 11? Just need to check that quickly. Okay. All right, then I'm going to answer question 2. Right. Get to fly, you guys were told parabola and straight line. Okay, so I'm going to obviously answer this question. Let's answer this question together, and then I'm going to transition into this one, which only has parabola and straight line. Okay, and then we're going to see maybe if we can't pull out some additions or add certain things so that we can actually also factor in other things that we should be aware of when it comes to functions. Because yeah, we can't be asleep to some important aspects of the functions, you know, important things that we need to know. So no, I don't. Do you need help, bruh? No, I just want people to answer the question 2.1. Can we all answer that question 2.1? Oh, I was struggling. Okay, 2.1, write down the coordinates of the turning point. Remember, guys, that this form of the function, f of x, let's just write it down. F of x is equal to 4 minus x plus 2, the whole thing squared. And let's do this. Okay. Let me get my piece of paper here. f of x is equal to, okay, let me first expose you to this then. You guys are struggling with the turning point. Your parabola, which is the happy face, sad face function, is written as a function in grade 11 and 12 in two ways. So in the first one is f of x is equal to a into x plus p, the whole thing squared plus q. So what you then can say is that for your turning point, all right, your x value of the turning point is basically the inverse of the p-value. It's like you take the expression inside the bracket, right? You equate it to 0. Then you solve for x. And your x value will be equal to negative p. So your x coordinate of the turning point is always the inverse of the p value inside the expression of the bracket. Okay, so this is one of your forms of your parabola in grade 11. Form 1 of the parabola is a into x plus p, the whole thing squared plus q. Then this q value here is actually the y coordinate of the turning point. The y what? Coordinate of the turning point. So we can say that the coordinates in this situation would be negative p and q. Does that make sense, guys? Can I just get an indication from those who are watching? Okay, you may have not known, but now I'm telling you that if you want the coordinates of the turning point for a parabola, if the function is given in this form, you have f of x is equal to a into x plus p. So if you want the x coordinate, take the expression inside the bracket, equate it to 0, solve for x, you get the x value of the turning point. Okay, it's always safer to take the expression, equate it to 0 and solve. All right, so this p, the inverse of p, is negative p. That's why we say the x coordinate of the turning point is negative p. Okay, the y coordinate, guys, of the turning point is going to be the q value as it is. So y is equal to q is the y coordinate of the turning point. So that's why we say that tp is negative p and q. So always take it in that way. The second form of your parabola function in grade 11 is the one that says ax squared plus bx plus c. When you want the turning point for this form, you have a formula. To get the x coordinate, you say x is equal to minus b over 2a. You check the x coordinate by using the formula minus b over 2a. The b comes from the standard form of the expression of the parabola. B, coefficient of the x term. A, coefficient of the x squared term. Then what about your y coordinate of the turning point? Well, you substitute the x value into the original function. You will get the y coordinate of the turning point. Following, that is for form 2. Form 1, you read the turning point. It is read from the equation. Form 2, you must calculate using the what? The formula minus b over 2a. That's how you get the x coordinate of the turning point. The way you get the y coordinate of the turning point, you take the x value, you substitute into the original function, then you will get the y coordinate of the turning point, right? Yeah. Now this is very important, guys. Okay. This is very important. It will help you a lot. So that's how you do it. So if we come here to this question that I said you must do, write down. You see, that's why they are saying here write down. So if I ask you guys to write down the coordinates of the turning point, what are you going to say? What are the coordinates of the turning point? in this situation, what are you going to write down? The coordinates of the turning point. Here's the function. Random is saying 2 and 0. Okay, negative 2. Okay, you're changing the 2 to negative 2. Abungile Mngoma says negative 2 and 4. Okay, so I give a round of applause to Melo as well. And Kiki, I see Kiki wanted to fix what Random had written as far as his y coordinate is concerned. So yes, guys, let's first rewrite. You go ahead and you first rewrite that function. Okay, I mean, you go ahead and first rewrite it. So we go ahead and we rewrite f of x is equal to 4 minus x plus 2 the whole thing squared. If we're going to rewrite this so that it is in that proper form, coefficient of x plus p seems to be negative. So we say negative x plus 2 the whole thing squared. That means the a value is actually negative 1. This 4 we can obviously write on this side. It is a positive 4. So we can say plus 4. When we see the function in its standard form, then it's easy to say the turning point is, remember that the inverse, the additive inverse of plus 2 is negative 2. The y value or the q value we said is the y coordinate of the turning point. So that means the y coordinate is 4. So that means our turning point of the function f of x is negative 2 and 4. Do you see, guys, that it is writing down the coordinate that we have to do here? Nothing more, nothing less. Because from the function itself, when it's in its standard form, all right, the turning, we call this form 1, we call it the vertex form or the turning point form of the function. Okay, the turning point form or the vertex form, because from it we read the turning point. Okay, we are good, ne? I hope we are good, guys. All right, I hope that's clear for all of us. All right, now let's move on to the next question. Any explanation? Anything that's not clear for anyone? Can we continue? Carry on? Yeah, so if the function is in this form, guys, our responsibility is to read the coordinates of the turning point. Okay, let's move on to the next question. The next question said, sketch the graph of f showing the intercepts with the axes and the turning point. So when you sketch, guys, here are a few important things. The function we now have is negative into x plus 2 the whole thing squared plus 4. The first thing is to check a is equal to negative 1. That means a is less than 0. So the shape that I'm expecting to see is this one, concave down. 2, my turning point I've just discovered is negative 2 and 4. 3, I need Mr. X intercept and my y intercept. I need them because they are basically not the same as the turning point. In grade 10, the turning point and the y-intercept were the same thing because my parabola in grade 10 was symmetrical along the y-axis. But in grade 11, all of a sudden, when you see the form of the function, it is slightly different because parabolas in grade 11, they move left and right, which means they do not retain that same axis of symmetry along the y-axis. So your turning point and your y-intercept will not be the same, especially when the form of the function is like this. You know, that plus 2 speaks to the movement of the graph. to the left by 2 units. This plus 4, states the movement of graph upwards by 4 units from the mother graph. So x-intercept, we always let y be equal to 0, because the x-intercept basically is on the x-axis. And we know that on the x-axis, the equation of the line for the x-axis is y is equal to 0. So we come here to the function, we substitute in the place of f of x, because f of x means y, right? We substitute in the place of y 0. So 0 is equal to negative into x plus 2, the whole thing squared plus 4. We maybe transpose the 4, we get negative 4 minus into x plus 2, the whole thing squared. We divide by negative 1. We get 4 is equal to x plus 2, the whole thing squared. We take the square root on both sides. When we do with the numerical value, we put plus minus. Then x plus 2 is equal to plus minus 2. There are two answers from this. Does x plus 2 is equal to positive 2? Or there's the x plus 2 which is equal to negative 2. The first value, I take the 2 over, 2 minus 2 is 0. The second value, I take the 2 over, x is equal to negative 4. Now, not all of you would have probably used this method. Take the square root on both sides. Remember, when you take the square root on both sides for an equation, for the numerical value, you must put plus minus to indicate that there are two possible answers. Okay, or you could have actually multiplied, open the two brackets, multiply out, transpose the term, get the equation in standard form, factorize, get the values of x. It would have still worked. Okay, still worked. So remember, this x is equal to 0 and x is equal to negative 4. Yes, because 94, you could have foiled, it would still have worked. You guys can do it on your own and see if you get the same answer. If you decide to foil the x plus 2, you get x squared plus 4x plus 4. You take the negative. Actually, let's do it, because I want you guys to see that either way it doesn't matter. Keep the negative. Let's square the first term, square the last term. Product of the 2 is 2x. You double it, plus 4. You distribute the negative sign, very important. Negative x squared minus 4x minus 4 plus 4 equal to 0. You add the like terms. Negative x squared minus 4x minus 4 plus 4 is 0. You divide by a negative. You get x squared plus 4x. You factorize. Take out the highest common factor. 0 factor law, x is equal to 0, or x plus 4 is equal to 0. Solve for x. X is equal to negative 4. So two answers. X is equal to 0, x is equal to negative 4. So it doesn't matter, guys, what method you decide to use. At the end of the day, both will give you the right answer if the mathematics is correct. If you don't make silly mistakes, if you are fluent in your mathematical workings, then it should be fine. It will lead you to the right place. Coordinates, therefore, for this one is 0 and 0. Coordinates for this one is negative 4 and 0. Those are the coordinates of the x-intercept and the x-intercepts. Okay, it would be the same even this side. Now I need to find my coordinates for the y-intercept. What do I do if I want to find the coordinates of the y-intercept? I let x be equal to 0. Then we come here and we substitute. F of 0 is equal to negative into 0 plus 2. Negative into 0 plus 2. The whole thing squared plus 4. Okay, negative into 0 plus 2, the whole thing squared plus 4. I am substituting 0 in the place of x for the function. So f of 0 is equal to negative into 0 plus 2, the whole thing squared plus 4. Let's check. 0 plus 2 is 2. 2 squared is 4. Times the negative is negative 4 plus 4, which is 0. So f of 0 is 0. So the x and the y-intercept coincide. It's 0. Okay. Now we are ready to sketch. Y-intercept is 0 and 0. So you draw your Cartesian plane. You have your y-axis, your x-axis here. You have 0 there. Okay, you have 0 and 0. So basically our x. Okay, let's go to our turning point. Remember, turning point we said is negative 2 and 4. Okay, remember we had identified all the things that we need. We know the shape is going to be concave down. The turning point, negative 2 and 4. So let's go and identify negative 2 and 4 on the Cartesian plane. Okay, we have Abongile, remember, our parabola does not have an asymptote. Remember, an asymptote is a boundary line, an untouchable line that is basically present in only two functions. The first function where we have an asymptote is a hyperbola. The second function where we have an asymptote is the exponential function. We do not have an asymptote for a parabola. That asymptote is reserved for your hyperbola. There's two asymptotes for hyperbola, vertical and horizontal. And then for exponential function, there's one asymptote which is horizontal. Parabola don't have asymptote. Okay? I hope it's clear, né? You are welcome, my dear. Very welcome. Okay, very, very welcome. I'm happy that I can be of assistance in that fashion. Okay, so I was wanting to identify the turning point. 1, 2, negative 1, negative 2. 1, 2, 3, and 4. X is negative 1. Y is positive 4. The meeting point for x is negative 2 and y is positive 4 is here. That's the turning point. That's where we are going to turn. Negative 3, negative 4. X is equal to 0 was the one x-intercept. X is equal to, let's just say, negative 4 is the other x-intercept. Okay, so this here is what we call our vertical axis of symmetry for the parabola. Then this is what we are going to say is negative 2 and 4, our turning point. We grab our pencil, we go up, we turn, we come down, and that is basically a representation of the parabola that is concave down. Are we together? Hello, Andile. Hello, Andile. Okay, I don't know why you are calling me out there at Maths again, but hi. So 0 and 0 is that x, but it's also a y-intercept, because remember, when we found the x-intercept, we got 0 and 0. When we found the x-intercept, we got 0 and 0. So the graph cuts the y-axis and x-axis there. Negative 4 and 0 is the other what? X-intercept. Okay. And then this is our graph. the equation of the axis of symmetry, x is equal to -2. Okay, yeah. So guys, I like drawing in the axis of symmetry. Okay, why? Because they may ask you questions like, for which values of x is the function increasing? The function increases where x is less than the value of the axis of symmetry. Where x is less than -2, the function is increasing. Where x is greater than -2, the function is decreasing. So the function increases here, then it turns, it decreases this side. But where x is greater than -2, it decreases for a concave down function. Where the function is x is less than -2, it increases. Okay, Melo, when you were asking about the SM, okay, just before that, okay, so let's just say we label the function f of x is equal to -x plus 2 the whole thing squared plus 4. All right, and then make sure that the marks for the x-intercept and y-intercept are well marked, and the marks for the other x-intercept are well marked. Okay, it's evident that it's -4 and 0. And then the shape, yeah, so you get marks for turning point, x-intercept, the shape. Okay, and depending on the generosity of the marker, you may get other marks depending on the amount of marks that are basically needed. Okay, yeah. Okay, any questions about that, the sketch? Okay, you know there was a lot of calculations, so they may factor in the fact that there was so many calculations you needed to do in order to be able to get the coordinates. So for instance, in this question, this was dedicated 6 marks. So which means that they factored in the calculations you had to do, finding the x-intercept, getting the coordinates of the x-intercept, that may be factored in. Right, finding the y-intercept, that may be factored in as long as there's accuracy. And then they check your sketch to make sure that the x-intercepts are there. You can see the y-intercept as well. You can see the turning point, that's very important, and so it goes. Okay, right. So the sketch showing, you did a very good job sketching and showing. All right. Let me continue with this, and then I'll explain the asymptote thing again. So we answered determining the coordinates of the turning point. We sketched the graph of f. Okay, we showed the x-intercept and the turning point and the intercepts with the y-axis. Determine the range. Okay. Now, guys, do you guys know what range is? Range. What is range? Do we know what range is? Range is the possible y values where the function, possible y values where the function exists. Or we say is defined from the bottom to the top. The possible y values where the function exists or is defined from where? From the bottom to the top. So let's go here. This is the y-axis. From the bottom here, we have negative y values. These are negative y values. So below the x-axis, they are negative y values. Above the x-axis, they are positive y values. So yes, from the minimum or lowest point to the highest point, That's how we measure range. Yeah, it's like from low to high, but low to high is from the bottom down there to the top. So if we look at this function, we see it here, down here, all the way to here. That is the maximum point that it reaches. What is the maximum? Let's say we asked, what is the maximum value of the function? What would you say, guys, is the maximum value of the function? Do we know what we mean by the maximum value? Okay. XVS, very good. The maximum value of the function is the top peak of the function. We look at the y coordinate of the turning point because that's the maximum. So we'd say the maximum value. If they asked you what the maximum value is, you say the maximum value is equal to 4. You look at the y coordinate of the turning point. Okay, that is your maximum. If the function was a smiley face like this, they wouldn't ask you here for the maximum. Here they would ask you for the minimum. But still, it would be the what? The y coordinate of the turning point. Because it just means the turning point now is at the bottom. Right? So here, they can ask for minimum. Here, they can ask, here they can ask for maximum. Here, they can ask for minimum. They can't ask for minimum here because there's a maximum. So if we now are checking range, what is the possible y values where the function exists? The function, because of these arrows, exists infinitely from the lowest of the lowest, which is not even a starting point. So the function will exist from let's say y, we'll say y is an element from negative infinity to what? To 4, where 4 is included. That is the range of this function. Or we could use another notation and say where y is less than or equal to 4. That is the range. Okay. From the bottom, which is not even a starting point, because negative infinity is simply a concept which shows that we're going on forever in that negative direction from those negative values. There was no beginning, quite, all right, even though there is a maximum end. Okay, so from negative infinity to what? To 4. Or we can say y is less than, meaning y, below y, we can find the function. That's what it means. Below the y value, which is 4, we can find the function, but also at 4. Does that make sense, guys? Yeah, I hope it makes sense. Okay, hope it makes sense. Baddest B. I see your question there, Baddest B. I see your question there. Okay, are we clear, guys? Are we clear about this? The range. Before I proceed and maybe even attend to Baddest B's question there. Are we understanding there? I'm going to explain that, Baddest B. Okay. Range is the possible y values of the function exist and is defined from the bottom to the top. Now, what if it was a concave up graph? All right, and let's say the y value was -4, okay, meaning the y coordinate of the turning point was -4. Then we're going to say y is greater than or equal to -4. Or we could have said y is an element from -4 to what? To infinity. Open bracket. We don't ever put a square bracket where infinity is. It's always open, because do we speak of a foreseeable end as we go up? No. We are going up forever. Like I said, infinity is not a number. It's a concept defining the ongoing nature of numbers in whatever direction. If it's positive infinity, it's in the positive direction, the ongoing nature. If it's negative infinity, it's negative values. Yeah. Right. I hope that's clear. Now, guys, look at this. The next question, I'm going to answer Bedesby's question. I just want to obviously complete the thought of what we were doing. Determine the range of P. Now, guys, anywhere here, do you see P? Is P something that you see there above? Is there any P that you were told about? Or are you coming across P for the first time in question 2.3? Exactly, there was nowhere where P was mentioned, but now it's being mentioned for the first time. But check what they are saying. Yes, Abongile, thank you so much for that comment. Sorry, I just had to attend to something, guys. Sorry about that. Okay, so P of X, this is very true. Abongile, you said it correctly, 100%. Let me clap for you. Okay, but how is it formed? This here tells us how this P of X function is formed. So forget about this negative for now. It's formed using f of x. But what are we doing to f of x? We are actually multiplying it by a negative. What does it mean to multiply this f of x in its entirety by negative? It means we are actually reflecting this function. We are reflecting this function. A change in the sign of y, because remember f of x means y, but of course it's a representation of the function. But this speaks of a change in the y value of this function. A change in y speaks of which kind or what type of reflection, grade 11s. I want you to tell me in the comment section. A change in the sign, remember f of x means y, a change in the sign of y for f of x speaks to which kind of reflection? What kind of reflection are we talking about? If the y value is the one that is changing, what reflection are we actually speaking about? Thank you, Abongile. It's a reflection in the x-axis, along the x-axis, about the x-axis. Maybe let me make this a bit clear. Reflection on the x-axis. Sometimes they say along Sometimes they say about. All of these are basically saying, reflection in the x-axis, on the x-axis, along the x-axis, about the x-axis. What is the x-axis? It is the line y is equal to 0. So even if I say it's the reflection along the line y is equal to 0, I must remember that the x-axis is having an equation, which is y is equal to 0. Okay, so practically speaking, guys, if let's say I have, in grade 9, you guys did transformation geometry. You did transformation geometry. If you have a point, let's say it's point A, and then this point reflects along this x-axis, it means that the distance from here to there is the same distance from here to there to the x-axis. Also, take note of the following. If A, let's say, was 2 and -4, the coordinates of B as the reflected, okay, let's say it's A changed, all right, A complement, which means there's something that happened to A, all right, would be 2, meaning x will stay the same. When we reflect along the x-axis, x stays the same, but y changes its sign. So we say that A complement is a typical reflection in the x-axis. So that's what a reflection in the x-axis does. It changes the sign of y whilst x stays the same. Okay, so graphically speaking then, when we say p of x is a function formed by the multiplication of f of x by a negative, what are we saying is p of x? P of x is actually the function of f of x, but the function of f of x reflected. So in words, we could say p of x is the function of f of x reflected because of this change of negative, which was positive, reflected in the x-axis. That's what it means, simply put. So therefore, what you will do, okay, to determine the range, if you are going to determine the range, you have this function negative f of x, which you are going to say, you are going to come here, you have the negative into x plus 2, the whole thing squared plus 4. So what you are going to do is you are going to multiply that by negative, all of it. So the negative will distribute here, the negative will distribute there. You get x plus 2, the whole thing squared, minus 4. Okay, which means the new turning point, remember now, A is currently positive. The function is no longer concave up, it's concave down. That's the first thing. Secondly, the TP, because now we have a maximum, not a minimum, the TP is -2 and -4. The range, therefore, of this new function p of x, by the way, this new function p of x, we said it is equal to the negative of f of x. The negative of f of x is x plus 2, the whole thing squared, minus 4. Do you see how we got it? Do you see p of x, the new function? Do you see how it is? Do you see its new turning point? Do you see its maximum? Therefore, what is the range? We can say y. Tell me, guys, what is the range then? Because they wanted from the question the range of p. if p of x is equal to negative f of x. Right? So what will be very careful, guys. Be very careful. You see, it's concave down now. So our range will be y is less than, not greater than, less than or equal to -4. So you see, most of you are saying greater than or equal. No, less than. Melo and Abungil, be careful. Oh, sorry, I think Melo was the one that got it right. But Abungil, at first, and Melo, yeah, you kind of lost it, eh? But take note, so the affected change, it's always nice to see, okay, this negative, it's affecting f of x. So let's take f of x, all of it, and multiply by negative so that we can see what happens. How many terms in this expression of the function? There are 2 terms. So when you distribute, you are distributing to this first term, the change of negative to positive. That means a is 1, which means it's greater than 0. Concave. Oh, my bad, guys. I am the one that misled you. A greater than 0, concave up. Yo, guys, sorry. Yo, who's sleepy? You guys were correct. Why didn't you have the courage to say, sir, you are speaking nonsense? Why didn't you say, sir, you are speaking absolute rubbish? You were more than welcome to do so. You were so 100% correct, guys. Why didn't you stand your ground? Why didn't you stand your ground, guys? Why didn't you stand your ground? Let's changes her answer because I am speaking and I'm saying, but your logic is telling you what it is telling you. Why didn't you have the courage to say, sir, you're speaking absolute rubbish? Okay. Yeah, guys, you were right, man. Concave. If a is equal to 1, positive, we are smiling. We have a what? A minimum. So what are we saying? Y is greater than or equal to -4. Not what I said. Not what I said. Okay. Okay, please, guys. Yo. All right. So I'm proud of you for actually giving the right answer. Me, I was lost in the maze of my own confusion. All right. But then quickly I saw, hi, man, there's something I'm saying here which is not making sense. And that's when it hit me. Hi, man. We're supposed to say y is greater than or equal to -4. Okay. So thank you for that. Okay. Now, I want us to... I don't know if I want to attend to this because of the fact that, like I said, there's this... But let's check this out. Sketch the graph of G showing the asymptotes and intercepts with the x-axis. Draw the graph on the same set of axes as the graph of f. Okay, so they want us to draw this graph on the same set of axes. The graph of G. So we have a hyperbola there. Now let me explain this thing of your hyperbola. Your hyperbola, remember, for those who are writing only parabola and straight line, this is basically not so important for you, but it will be in future. So, 2 things. 1, this a here. Okay, so this is the standard form of a parabola, of a hyperbola. Okay, this is not going to be relevant for those that are not obviously doing this. So, a hyperbola, 1. Oh, I'm running out of data. Oh, Sherman. Abongile, were you the one that asked that question? Was it someone else? Oh, it was Bellis B. I don't know if Bellis B is still here. You're running out of data. I'm so sorry about that. That's such a pain. That's such a bummer. Because I'm thinking now, I can't focus on this question too much. We need to go to that straight line and parabola question, the other one. Okay, let's do that again. Because you are sorry guys. Okay. Okay. Let's focus a little bit here, because I don't want to be rambling on other functions to the demise of the other. Let's just come here. So here is another parabola, but this time round our sketch below shows the graphs of the following. F of x is equal to ax squared plus bx plus c. You see now our function of the parabola is given in the other form, not the turning point form that we had. Then we have g of x, but you see the parabola is not fully given. You know, we don't have a, we don't know b, we don't know c. Then it says the graph of f has its turning point at c. So f, we are given a turning point, cuts the y-axis at 0 and 5. So we have the coordinates of the y-axis, which is 0 and 5. The graph of g cuts, which means this one, cuts the x-axis at where? At d, and y-axis at d. So let's just check quickly. Then we are told EG is a line segment. EG is a line segment which remains perpendicular to the x-axis. So EG is a line segment, it's perpendicular to the x-axis. EF varies in length. EF varies in length. I'm guessing when you move this line here, it will be smaller, but the more you move it out, it will be bigger. So EF varies in length between any 2 points on the what? On the parabola and the line. That's why I'm saying, yes, if we move this line here, it will become smaller. If we move it out, it will become bigger. Okay. All right. So let's go to the question. It says, show that A is equal to half, B is equal to -2, and C is equal to 5. For how many marks? 5 marks. A is equal to half, B is equal to -2, and C is equal to 5. So let's come here and see something. The parabola, we are given C, which is 2 and 3, and we are given A, which is 0 and 5. And we were told that C is the turning point, right? C is the turning point, and the A is 0 and 5. So I think even though our function is given in this form, judging by the turning point and the other point, okay, we can basically use our function form, which says f of x is equal to a into x plus p, the whole thing squared, plus 2. Why can we do that? Because if you are given a turning point and one other point, okay, turning point and one other point, then we can basically find the equation of the parabola if we use this form. Okay, if we are given the what? The turning point and one other point. Remember, the turning point is given as C, 2 and 3. We have that. And then the other point is the y-intercept, which is, let's see, let's just check again. The y-intercept is 0 and 5. So that's A, 0 and 5. So let's do this. F of x. Is it f of x or g of x? Oh, it's f of x. F of x is equal to a into. Now, if the x coordinate of the turning point is 2, we write here x minus 2, the whole thing squared. Remember, if we were writing down the x coordinate, we'd have to take this x minus 2, equate it to 0, and get the positive value. The additive inverse of minus 2 is the x coordinate of the turning point. Then y coordinate, remember, y coordinate resembles with the q value, which is 3. So guys, even though I am given the function in this form, because of the coordinates I've been given on the actual graphical sketch and the information. All right, I've been given the turning point, which is 2 and 3, and I know for this form the inverse will fall here, it's -2. The y coordinate will fall here, it's +3. The only thing I'm missing now is to find the a value. I mean, to find this a value. And to do that, I am going to substitute the coordinates of a, because 0 is x, 5 is y. So I'm going to come now and substitute this and solve for small letter a. So what is the lesson here? The lesson is this. Yes, Abongile. If we have the x-intercepts and one other point, that's where we would use what Uletu has said. Okay, but the condition where we have a turning point and one other point, we use this form to find the equation of the function. Then we are going to expand so that we can get it into the standard form. I repeat this again. What Letu has said in the comment section about a into x minus x1 into x minus x2, that form is used when you want to find the equation if you are given the 2 x-intercepts and one other point. Unfortunately for us here, for this function, we are not given x-intercepts. We don't actually even have, and we are not going to be able to have x-intercepts for this function because this function does not cut the x-axis. So with that knowledge in our heads, we have the turning point and we have one other point. So when we have that, it is then just logic that we use the turning point or the vertex form to try and find the equation. We substitute the inverse of the x-coordinate in the place of p, right? The additive inverse, which is basically -2. Then we substitute the y-coordinate of the turning point in the place of q as it is. Then we use the other point 0 and 5, okay, to basically then substitute and solve for a. So if we were given -2 and 3, we were going to write f of x is equal to x plus 2. Yes, the whole thing squared. And remember the a, don't forget the a, ne? We would say a into x plus 2. Yes, we would do that. The whole thing squared. And then we would write the +3 there in the place of 2. So that's correct. UFW Judith. You're 100% correct there. Okay, y coordinate is 5 equal to a into the x, that's 0 minus 2, the whole thing squared, plus what? Plus 3. We transpose the 3, 5 minus 3 is equal to a into 0 minus 2 is -2 squared. You square the -2, you get +4a. 5 minus 3 is 2. You divide, actually we will not have -4a, it's +4a, because remember -2 squared is +4. 4 times a is +4a. So we divide both sides by 4. We get a is equal to half. I believe that's what they wanted us to show. I believe a is equal to half was one of the parameters. A is equal to half. There it is. Yes. Woo! Woo! Guys, it's getting there. Now that we have half, we go and write our half in its place. And then we expand. X minus 2 here. We square the first term. We square the last term. The product of the two, x minus times minus 2, is -2x. We double it. We get -4x plus 3. Okay, makes sense, guys? Yeah, this concept of square the first, square the last, you product of -2. Okay, Abongile Ngoma is saying no, it doesn't make sense. Abongile, we just found the value of a. Does the value of a, finding the how we found the value of a, does that make sense? Because you are saying nope. I'm asking you, does the value of a being equal to half make sense? Okay. What part are you not saying it doesn't make sense? Okay, the value of a being half makes sense. Now you take the value of a, you go back where? Here. Right? This was waiting for a to be found. After you substituted this, we are now waiting for a to be found. Once we get a, we go back and we substitute here. F of x is equal to half. A is half. Then you have in brackets x minus 2. But this x minus 2, you open two brackets. If you open two brackets, you FOIL. You should get x squared minus 4x plus 4 inside the brackets. So I usually say the shortcut to this is you square the first term, square the last term, -2, you get +4. Then the product of 2 and -x is -2x, you double it, you get -4x. Okay, so this is just a shortcut for the FOIL, because hey guys, anything that can shorten our time and help us to get to the answer is helpful. Now, BODMAS, you distribute the half to all three terms. You get half x squared. A half times -4 is -2x. A half times 4 is +2. Then brackets have been removed, you add the 3. What is the final answer? Half x squared minus 2x. 2 plus 3 is 5. So that is the function of f of x. We revert back to what was stated, and we try and make sense of this in light of that. A is half. A is half. B is -2. B is -2. C is +5. C is +5. So this here is the function of f of x. Okay. For finding the value of b, we can also use the formula of x coordinate of the turning point is equal to the -b over 2a. Yeah, very true. You could, Melo. But yeah, you could. Definitely you could. Next question. Determine the length of AB. Now, AB is a vertical line. AB is a vertical line. We have the coordinates of A. We are missing the coordinates of B. How do we find the coordinates of B? So that we can then calculate the vertical distance of AB by subtracting the y coordinate at the top and the y coordinate at the bottom. So how do we find the coordinates of B? Okay, so we look at where B is, right? And we ask which function cuts through B. So you can see the function that cuts through B. Okay, and where does it cut it? Yes, the y-intercept. So what do we know about the y-intercept? There is a coordinate we already know because it is a y-intercept. B is where the y-intercept would emerge. Okay. So what do we do, guys? We find B first. Okay. And I think it's straightforward. Okay. If we let x be equal to 0 for g of x, Okay, we let x be equal to 0. We say g of 0 is equal to 2x minus 2 of 0 minus 4. Okay, that gives us negative 4. So b is 0 and negative 4. A we already have. It is 0 and 5. So we say AB is equal to YA, which is at the top, minus YB, which is Y at the bottom. Why can we do this? Because it is a vertical line. Your x values are the same. The only thing that's different are your y values. So you say y at the top minus y at the bottom. Y at the top is 5 minus 4. So we say 5 plus 4, which is equal to 9. 9 what? Units. Okay, this is how we find distance of vertical lines. If you ask me the question, would it be fine if I use the distance formula from your analytical geometry? That's fine, you can. Okay, because at the end of the day, it's coordinates. And if you've done analytical geometry already, you are well within your rights. Okay, but this is the distance for how we calculate distance for vertical lines. Horizontal lines, it's x right, because we're seeking to subtract the smallest value. So that would be the x value on your left. We subtract it from the biggest x value if it was horizontal distance. For vertical distance, y at the top minus y at the bottom. We take the big minus the small value. So that's how we get 9 units. Okay, clear? Yeah, right. And the logic here was that we wanted the length of AB. Where's A? We already have the coordinates. Where's B? We don't have the coordinates. It's a vertical line. So we need y at the top A minus y at the bottom B. And then that difference will give us the distance of AB. Let's go to 7.3. Determine the possible lengths of OG if EF is 9 over 2. Where's OG? OG. Determine the possible length of OG. If what? Yeah, cheers. Among you're writing tomorrow as well? Is that grade 11 you're writing? You're writing this morning? I'm very sorry about the data running out here. You're welcome, Abungi. Thanks for your participation. It was really, it was heartwarming. Thank you for being here. Oh, you're not writing. When are you writing? So you still have a ways. Okay. Hopefully you can get your data issues sorted and you can return at another time. You're in grade 11 or grade 12? Is 11 or 12 that you're in? Okay, so possible length of OG if EF. Where's EF? EF. Grade 11, okay. And when are you writing? Sticks is writing today. You're writing on Friday. So paper 1. Grade 11 or 12? Just confirm the Melo. Grade 11 or 12. Determine the length of OG or 11, okay. Determine the possible length of OG if EF is equal to 9 over 2. Now let's check the mark allocations, 5 marks. Yeah. So you take the equation of the function, you subtract the equation of the straight line, because it's y at the top, which is the y coordinate of E, minus y at the bottom, which is the coordinate of F. But we don't have any coordinates here, so we are going to take the function to represent the point. We say this function, f of x, very important what I'm saying here. So we say this function, f of x, because it's at the top. This is like saying y at the top, minus g of x, which is like saying minus y at the bottom, is equal to, so remember they said that if the length, determine the possible length of OG if EF is 9 over 2. So we're going to say f of x minus g of x is equal to 9 over 2. F of x, we got the equation was half x squared minus 2x plus 5, then minus g of x, we put it in brackets because it's a binomial expression, 2x minus 4 equal to what? 9 over 2. Since we have an LCD of 2, we multiply each term by the LCD. Why? To get rid of the denominator. Times 2, we get x squared. Times 2, we get negative 4x. Times 2, we get 10. Times by 2, we get negative 2 here, which if you distribute, you get negative 4x. Negative 2 here, which if we distribute, you get plus 8. Equal to what? Okay, or we can say minus 9. Because if you times 2, we get 9. So we transpose that, we get minus 9. Then let's get our standard form. In x squared minus 4x is minus 8x. 10 plus 8 is 18. 18 minus 9. 10 plus 8, 18 minus 9 is 9. We will solve for x. We factorize. Remember, positive sign means same sign. Same sign according to who? The sign of the middle term. So we say minus minus, factors of 9. Ooh, something is off here. What is off? Minus 4x is negative 8x. Okay. 10 plus 8 is 18. 18 minus 9. Yeah, guys, 9 and 1 won't work. Okay, something is... Okay, let's just check again. Half x squared minus 2x plus 5 minus 2x plus 4. Okay, minus equal to 9 over 2 because that was the distance of EF. I just want to check again. X squared, remember when you multiply by 2, we get x squared minus 4x multiplied by 2, we get 10. Multiply by 2, you get negative 4x. Multiply by 2, you get positive 8, which is equal to the 9 over 2, which you times that by 2, you got 9. You transpose the 9, you got negative 9. Okay, let's just do the maths one more time. X squared, that's fine. Negative 4x minus 4x is negative 8x. 10 plus 8 is 18. 18 minus 9 is 9. Alright. So there must be some offish thing that happened there. 9 and 1 will definitely not work. Okay. 9 and 1 won't work at all. It's not feasible. So there must be something that yeah, even if, okay, so if I use the quadratic formula, x is equal to minus b, let's go ahead. Melo. Let's go ahead and see. 2a. So minus b squared 4ac 4ac over 2 times 1. We get 8 plus minus. Okay, thank you guys for recommending that. I think I was lost myself. I was like besides myself. 64 minus 36. Okay, let's just put everything inside there so that we have the answer. 8 plus the square root of 64 minus 36. Sorry, divide. Okay, let's divide the whole thing by 2. 4 plus root 7. So 4 plus root 7. Of course, if we change the whole entire thing, so let's just say 8 minus the square root of 64 minus 36 divided by 2. We get 4 minus root 7. Okay, then if we look at it in light of where we are at that particular distance, just check what is this in decimal form. 4 minus root 7 is equal to 1,35. So this is like x is equal to 1,35. And then let's check this side. 4 plus root 7. So if we change the minus to plus, we get ST6,65. Okay. And I'm just trying to think which x value seems more plausible. Would it be 1,35 or 6,65? Because if we look at 1,35, remember x coordinate at this point can't be less than 2, and this one is less than 2, so x cannot be 1,35. X is going to be 6,65. That's the one we have to accept, 6,65. So let's just keep it as 4 plus root 7, okay? That's the x value. That means the E, F, and G lie on the same vertical line. So the reality is we wanted what? We wanted the length of OG. We want the length of OG. So if we want the length of OG, we're going to care about the x coordinate of G, which is 4 plus root 7 and 0. Okay, let's just write it in third form. 4 plus root 7 and 0. So that is the coordinate of x coordinate of G. O, on the other hand, has the coordinates 0, 0. But of course, our distance of OG is actually going to be x on the G minus x on the O. So 4 plus root 7 minus 0 is actually 4 plus root 7, which is 6,65 if we round off units, if we round that off to 2 decimal places. So let me explain this, guys. Right, from the top at the beginning. Remember, from the top on the beginning, they're saying determine the possible lengths of OG if EF is going to be equal to 9/2. Right? So what I end up doing now is I am told that the distance of EF is 9/2. So in terms of x, what I do is I take the parabola function, which is having a point of E lying on it, and the coordinates of f, or the point f, lies on the straight line. This function is above this one. So I can say, if I want to calculate the distance of EF, this function of f of x, which is what I wrote right there, minus this function at this point of g of x. These two, the difference of these two functions at EF gives me what? A distance of 9/2. So then I substitute the functions, both of them, okay? And then I distribute and simplify. I get the equation of x squared minus 8x plus 9 is equal to 0 in standard form. Then I have to use the quadratic formula to find the x values. But what are these x values? These are the potential possible x values for the distance of EF. The potential possible x values for the distance of EF. So I get 6,65, which seems to be slightly bigger than, for instance, this value of C, which is the turning point, which is 2. So to say that basically that the x values on E are 6,65, or that 4 plus root 7, it means the x-coordinate of F is the same and the x-coordinate of G is the same. Why? Because on the same vertical line, we know that the x values, they are the same. Okay, so that's why we end up now finding ourselves having the x-coordinate of G is 4 plus root 7, accompanied by the y-coordinate, which is 0, because on the x-axis there, the x-coordinate is obviously that 4 plus root 7, but the y-coordinate on the x-axis is 0. But remember, for a horizontal line, okay, so if EF and G lie on the same vertical line, that's why we embraced G, the x-coordinate of G, as 4 plus root 7. Okay, obviously its y-coordinate will be 0 because this is lying on the x-axis. Now if you compare GO, remember OG is a horizontal distance, which we can use the x-coordinate of G, which we know is 4 plus root 7, subtract 0, which is the x-coordinate of O, and get the distance of OG, which is 4 plus root 7. Rounded off to 2 decimal places is 6,65, and that's fine. I think, guys, in the next 15 minutes, I will definitely have to end the live, right? Because, I mean, yeah, I can't push beyond that. I think some of you, I'm sure you're feeling it, honestly. Yeah. Okay, and I don't want to be the cause for you not arriving at the venue with your best sort of like mindset there. You're dead tired. Let's look at 7.5. Determine the minimum length that EF can assume. The what? The minimum length that EF can assume. Okay, guys, when we are asked to do that, there's nothing much to that. The minimum, if they ask you for minimum, then you need to find first and foremost EF in terms of X. Okay, I'll do this live again tomorrow, Melo. Do another one though. Remember that everything I do here, I upload the video of this live lesson onto my YouTube channel, and you can go and rewatch or watch certain aspects you may have missed, or which you were sleepy when you were watching me explain. Okay, so just remember that. But I'll probably upload the lesson during the course of tomorrow. Okay, I uploaded the one from yesterday. Okay, I start the lives at 10 or 10:30, and then push and see how far we can go. But I think I'm going to end with this question as the last one. Okay, because yeah, determine the minimum length of EF. So what you do is we take EF and we say f of x, because f is at the top, minus g of x. So half x squared minus 2x plus 5 minus just the 2x minus 4, which is the function of g of x. We put it in brackets. Then we get half x squared minus 2x plus 5. Distribute the negative 2x plus 4. Add like terms. Half x squared minus 2x is minus 4x. 5 plus 4 is 9. Then when we are here, we have the quadratic expression of EF. To get the minimum would make sense. They said they wanted the minimum length of EF. It makes sense that they would want the minimum length, because how do you get the minimum? If you have the quadratic expression, your desire is to get the turning point. Okay, in term 1, you did this thing of finding the value of the minimum by completing the square of the expression. But you see, guys, we don't necessarily have to complete the square of the expression. You can do so if you want to. Then you can get the value of 2 is the one that will give you the minimum, which is the minimum of EF, because EF represents this function. So the shortcut now, what we can do is we can say, and take the formula for the x coordinate of the turning point. Say x is equal to minus b over 2a. Then we substitute b is a -4, but we multiply with another negative that's already there. A 2 times half. We get 4, 2 times half is 1. So that is 4. Okay. Then remember, you take this x value, which is 4, which is a representation of the x coordinate of the turning point of this quadratic expression. You take it, you substitute it in the place of EF. This will give you EF minimum, because substituting the x value, which is 4, for a, look at the coefficient of x squared. It's a greater than 0, which means concave up, which truly speaks of minimum. So this is the x value of the turning point. Now we need to take this x value, substitute it back into the function, so that we can get the corresponding y value, which is a representation of the what? The minimum. Remember, guys, why is it the minimum? A here is greater than 0, it's concave up, smiley face, so there's a minimum there. But we get it by substituting this x value, which we got from the formula x is equal to minus b over 2a for this form of the quadratic expression for EF in terms of x. So we substitute now, half into 4 squared minus 4 into 4 plus 9. That's the minimum. All you do, I just grab the calculator, guys, to make life easy. 16 divided by 2 is 8, minus 16 plus 9. Then 8 plus 9 is 17. 17 minus 16 is 1. That's the mean. The minimum length EF is equal to 1 unit. Okay, we together. Minimum length of EF is 1 unit. Straightforward, this one. Straight. Straightforward. Okay, so once again, all you do is you take the function at the top and the bottom, because EF is a vertical line or vertical length. It's y top minus y bottom. You get the expression in terms of x, the quadratic expression. You use your formula for finding the x coordinate of the turning point. After you find it, you substitute it back into the original expression for EF, and that will no doubt give you the minimum value, which is 1 when you substitute 4 in the place of this quadratic expression, which is a representation of the minimum length of EF. Okay, the last question, 7.5. This one, very cool question. We are saying determine the values of k. We are back in nature of roots. Determine the value of k for which this equation, the whole entire thing, has real and unequal roots. Real and unequal roots. Real and unequal for a parabola means there are 2 distinct roots and they are not equal. All right, and that's for half x squared minus 2x plus 5. All right, which is basically a representation of f of x. So half x squared minus 2x plus 5 equal to k. So that half x squared minus 2x plus 5 equal to k. This here represents f of x. Okay, that's what it represents. And f of x means y. So as long as this k, this side, is isolated, we are good. And all we are doing, guys, for this, we just need to know, so the shape of the function is like that. The turning point is basically 2 and 3. And we are checking things for a horizontal line y is equal to k to check where does it have real and unequal roots. So it will always have real and unequal roots. Okay, right? This is y is equal to 3, sorry, this horizontal line. But as long as the line is above y is equal to 3, okay, remember y is equal to k, so we can say even as long as the line, the horizontal line, is above k is equal to 3, because y represents k, k represents y. So this horizontal line is y is equal to 3. Here we have one real root. Above that line, y is equal to 3, we have real and unequal roots. Where? That's where k is greater than 3. In other words, that's where y is greater than 3. But since they want the answer in terms of k, determine the values of k. The answer is k greater than 3. Okay, because always above, right? And it's important to just know the turning points. We need to know specifically the y coordinate of the turning point. We judge our answer based on the y coordinate of the turning point. With f of x isolated, the entire function represented, and then the k isolated on the right, we can then define where is this line where the function will have 1. 2 has real and unequal roots. Real and unequal roots is found above the line y is equal to 3. Okay, because y is k, we can say the point where, or let me say, the values of k for which the function has real and unequal roots is where k is greater than the y coordinate of the turning point. But guys, if you are struggling with doing this graphical representation, you can always take the entire equation, write it in standard form, then you basically say delta is greater than 0 for whatever expression you get of delta. For real and unequal, that means delta is greater than 0 alone. Then you solve for k for that. Okay. Please, can I see the wild paper? What wild paper? Or for this question? Can you see? Okay. Yeah, guys, I'm gonna hold it right here. Okay, thank you for joining in. It's 4 minutes to 2. Yeah, guys, everything of the best as you write. If you guys are writing today, everything of the best. Yeah, do your best. And yeah, thank you so much for being part and parcel of this live lesson that we did just now. Yeah, me has to go. Me has to vamos. But explain on 7.3, why did you multiply the equation by 2? The reason why I multiplied the equation by 2, Galop, my guy, is that, you're welcome, 7.4 is 4 marks, the minimum length. This one, minimum length, 4 marks. It's 4 marks there, you see, 4 marks. Okay, 4 marks. Oh, good marks. Why did we multiply by 2? Guy, look. Okay, when you have an equation, the whole point is to get rid the denominator, man. It's always problematic. Okay, so in any equation, if you can see the denominator, there's an LCD of some sort. You see, there's 2 and 2. It would be nice if we can get rid of the denominator so that we don't have to deal with fractions. We deal with an equation where there are no denominators. That's why we did that. So our LCD was 2. And when you have the LCD, you multiply by that LCD in the numerator for all the terms in your expression. So we multiplied by it here, we got x squared. Multiplied by here, we got negative 4x. By here, we got 10. We multiplied it by this bracket, we got negative 2 outside, which we distributed and got negative 4x and positive 8. We multiplied by 2 there, we got 9. Does that make sense now? Are you understanding why we multiplied by 2? Fraction equations, guys, it's better to solve, because the whole point of a fraction equation is to either lead us to a quadratic equation or a linear equation that we can solve, that is devoid or does not have a fraction, you see? Because fractions make life complicated if we are still lurking around and we do not simplify. Okay? Alright guys, let me love and leave you for the love of the maths. Okay? Yeah, thank you guys again for joining. Thanks for the gifts, those that were able to gift a rose there and a you awesome there and other heart me's, GG's, TikToks and all of that. So thank you so much guys. Very generous, very kind of you. Please take care of yourselves and I'll see you again in another segment or session. We only multiply when the denominator 2 is outside. Yeah, I don't understand what you mean by only multiply when the denominator 2 is outside. I don't understand what that means. I don't understand what you're saying. Because my guy, the 2 could have been inside in a fraction. Okay, it could have been inside. The whole point is that if there's a lowest common denominator, we multiply by it. Okay, we first look at all the terms and check. Denominator, there's 2 there. Minus 2x. Okay, there's no, it's 1 the denominator, so it doesn't have 5, 1. Negative 2x into that one, it's 1 in the denominator. Then the 2 there, here, there's an outside 2 and an outside 2. But even if it's in the middle, guys, you always check the denominators, find the LCD, and it's the LCD that you multiply by so that you can get rid of the denominators. Okay. You guys, cheers. See you again. Bye.